Hello everyone and welcome to yet another recreational programming session with Mr. Azozin as usual. So, on the previous stream we did a little bit of a Crust. Right, so for those who don't know, Crust is a version of Rust where we fully give in into unsafe. Right, so let me actually show you an example of Crust. I think it was somewhere here, so here is, no, it's not here, so here it is. So essentially we have a bunch of rules in here, is that every function is unsafe. We do not use any references, only pointers. We do not use the std library, we use only libc. Right, and point is immutable by default. I'm really not sure about this specific rule, right? So it's kind of an optional rule. So let's actually put opt. Maybe at some point we're going to remove it. But I suppose these three rules are like very important. So this language is called Crust, right? So, and it's a variant of Rust that is comfortable for C developers to work with, right? So because in that mode, Rust ceases to be annoying and starts to become actually usable language, right? So that is actually enjoyable to use, right? So the problem with Rust is that it achieves safety by sacrificing the sanity of the programmer. Right, so that's how it achieves safety, right? So just it becomes absolutely fucking unusable, annoying, shitty language, but at least it's safe, right? So just like fuck programmers, fuck programmer mental health, safety above all. Think about the children, think about the children, right? So we're kind of trying to go in the opposite direction, right? Let's actually cut out all of that bullshit. Let's actually, for once, think about the mental health of the programmer and just let them enjoy. Right, and with the rise of vibe coding, it is obvious that nobody gives a shit about safety anyway. So why should we? Am I right? Why should we? So, but on a serious note, I do not recommend using this kind of variant of Rust for like a, security critical applications. Just saying, this is more for recreational programming. Right, and I was thinking, like, we did a little bit of stuff in this, right? So we implemented a simple, like, hello world, we implemented dynamic arrays, everyone. Dynamic arrays, we implemented dynamic arrays, so where it is here, dynamic arrays, and we also actually called some array functions and stuff like that. Nothing particularly fancy, right? So just basically hello worlds. And I was thinking, what would be more complex than hello world? And I was going through my to-do list of things to implement, and I stumbled upon a thing that I wanted to implement for quite some time. So not everybody knows that, but before C programming language, Ken Thompson actually created a B programming language. So why do you think it's called C? Because it comes after B. So B is sort of like a prequel to C. It is prequel to C, right? So, and the language is not even used anywhere. This is one of these rare languages that is actually dead. So the thing about programming language is that some time ago I said that languages never really die. They never really die because they usually accumulate enough like a legacy code that keeps them going. The same with the COBOL, for instance, right? So people say that COBOL is dead. In reality, it's not. There is a lot of legacy code bases that actually keep COBOL alive. So in the languages, because of that, are not really dead. But B is actually legit dead. Nobody uses it. And as far as I know, there's no really like official compilers. There's no compilers at all. Maybe some enthusiasts actually implemented some compilers for B, but I mean, it's kind of difficult to verify that this compiler is on spec. And in fact, as far as I know, there was never a spec for B. Right. So, but what there is, what I found is the user reference to B written by Ken Thompson. So he basically wrote like a manual, like a reference for the language, and he described the language, and he also provided a bunch of examples of programs here. So here are the programs in B, and they kind of look like C, except you don't specify types, because if I understood correctly, there's no types in this language. Well, I mean, there's only one type. It's a word, a machine word. Right, so, and when you define variables, you basically define a variable of the type word, and you only use words in here. So when you use auto, by the way, auto was in B, but it was not, well, it was in C, right? So I was trying to make a joke that B was ahead of its time, but I mean, C also has auto, but it's kind of meaningless, right? So the point of auto is that it's an automatic variable, meaning that as soon as you go outside of the scope of the function, it's going to be automatically deallocated from the stack, which is the default behavior of all of the modern programming languages. we usually do not explicitly manage stack variables anymore in programming languages, right? And a lot of people don't even remember that was a thing at some point, right? So, but we don't do that anymore. So because of that, in C, this keyword is kind of actually useless, especially in C++, and that's why in C++ it now means a different thing, right? So, and auto just means that it's allocated on the stack, and when the function exits, it's deallocated from the stack. And the reference for this language is rather simple, actually, right? So it's not that big, right? If you try to print it, it's actually 21 21 pages. Is that how we say it in English, right? So I don't know, 21 page. And I was thinking, what if we just implement a simple compiler for B programming language in Crust as an exercise in Crust, right? So because I wanted something more complicated than Hello World, there you go. Here is the project that I also wanted to implement for some time. I think it's a, it's a match made in heaven, right? It's a match made in heaven. Two meme languages together synergize each other, so I think we can get something cool out of that. But obviously, developing programming languages is not an easy task, and I'm pretty sure we won't be able to finish the entirety of the B compiler within a single session, right? So I'm not that cracked of a developer, right? I actually don't consider myself to be cracked developer, so I don't think I'll be able to implement the entirety of this thing in Crust in 2 hours. And I was thinking, what if we implement like a small subset of B on today's session, and then we see if we want to continue this project or not. Like we'll see how it goes, right? So that's basically for the idea for today. Let's come up with a simple program, like a simple example, and let's make that specific example compilable. My usual approach, right? So every time I implement languages, I start with a very, very simple example, and I implement enough of the compiler to compile that specific example, right? And then once I get that specific example, I can put some more meat on it until it sort of resembles the final product, so to speak. So that's basically going to be the goal for today. Let's go ahead and do that. And obviously we're going to be doing that in Crust. All right, so how are we going to be calling it? So it's actually called B. So I'm going to create a folder called B. B. All right, so let's create maybe main.b. And if I understand correctly, right, so this is the entry point of the B program. So let's actually find some examples in here. So here are some examples in here. So they even try to, yeah, so apparently B doesn't have variadics. Yep, so that's an example of printf, apparently. That's an example of printf. That's very cool. So I need something simple. Let me scroll up. Yeah, so here is the entry point. And we also have external keyword. Right, and one of the functions that exist in standard library that when you link this entire thing is putchar. So we can take a look at what XTR even means, right? So there was, yeah. So external declarations, and more broadly, we have declarations. So declaration in B specifies storage class of variables. Such declarations also in some circumstances specify initializations. There are 3 storage classes in B. Automatic storage is allocated for each function invocation. Yeah, so basically stack storage, right? So it's stack. External storage is allocated before execution and is available to any and all functions. Internal storage is local to a function and is available only to that function, but is available to all invocation of that function. So I suppose internal storage is basically static variables, right? So you can actually, even in C, define static variables, right? And essentially they are available to all invocations of the function. So that's probably what they're referring to. It's just like they're using a different terminology. So an external declaration so has this form, external and a bunch of names, right? So these are external names. The external declaration specify that each of the named variables is of the external storage. The declarations must occur before the first use of each of the variable. Each of the variable must also externally defined. So I suppose this is just like as external names for the linker, at least for us, right? So this is external names for the linker. Okay, so let me find extern put char. So extern put char. So here it is, right? And in here we just declaring that we expect put char to exist somewhere, right? So this is what we expect in here. And I suppose this function, I'm gonna make a wild assumption. I'm making absolutely wild assumption, works exactly as the put char in C, right? So it accepts some sort of an integer and just prints that, you know, the ASCII, the character that is associated with the ASCII code within that integer, right? So, and that's what it is. It just prints the character that you provided. Anyway, so let's actually define something like this. So put char. And what I want to do here is, I suppose I want to define two automatic variables, A and B, right? A and B. And let's just write a very simple program in here, right? So I'm going to assign 34 to A, and I'm going to assign 35 to B, and then I'm going to do put char A plus B, right? So this is a very simple program, like a very simple hello world. And let's write a compiler that compiles that specific thing. Right, so this is a B program, right? If I understand correctly, so all of that should work in here. So you can also do this kind of thing. So I have no idea what that's supposed to mean. Right, it's rather interesting. Oh, look at that. So we externally declared N and V, right? And then we actually defined them here. So you can also use externs as a forward declaration. This is actually rather interesting. This is actually rather interesting. And all of the variables are initially integers, right? So, and you can also have arrays. And this initialization, look at this initialization, doesn't have equals. I'm not really sure if that's a correct thing. As far as I know, this entire document was basically scanned with OCR. Right, so it was not typed as it is, right, in a digital form. It was actually just like on the paper. So, and then they digitalized it through OCR, so maybe some of the things might be missing. So we have to kind of keep that in mind. So because of that, I'm not really sure if that's a really correct thing in here, right? So initialization of this variable without any equals, maybe OCR didn't recognize this entire thing. So it's kind of difficult. See, it's a dead language, right? So it's kind of a dead language. So there's an original, so check the original file. Is there an original file, an image? Okay. So, but it's kind of difficult to, so there's a PDF in here. Maybe I should actually download PDF. Damn, that sucks. Okay. I wonder, okay, so it is searchable actually, believe it or not. Extern put char. So we found this thing. Look at that. No, there is a space in here straight up. That is fascinating, honestly. That's okay. Can I save this? I can't really save that. Maybe I can. So I don't see how to save the whole thing. So this save page as, and this is, or whatever, right? So we're using Wayback Machine, so we don't really need to save it. Okay, so let's go ahead and just try to maybe read the file. Second button from the right to save. From the right. Here it is. Okay, so you see, I'm an old computer user. I expect the save button to look like a floppy disk. None of that Zoomer download folder cloud shit. Get the fuck out of here with that. Get off my lawn with that shit. Where is the freaking floppy? Anyways, okay, so let's actually download that. But I mean, for real, it's just like so many, I know. And I'm not even joking, by the way. I legit was actually looking for floppy icon. That's how fucking old I am. Anyways, so we have that. I already have a copy in here. Okay, so let's go ahead and just like create main our ass. So I suppose we need to start with fn main. So this is the entry point. And I don't remember, like I probably have to do extern C, right? And also have to make it unsafe. I need to have my libc bindings, right? So here is the crust, and I'm gonna grab my libc bindings. Also, I should have actually provided like no mangle and stuff like that. Okay, the signature is actually more complex than I put in here, so let's actually make it like this. And obviously not going to be using command line arguments yet, but maybe at some point. Okay, so here's the libc. I need my libc in here. Maybe at some point it will make sense to actually like factor it out to a separate file of some sort, right? So I don't have to copy paste it around all the time. All right, so in here I return just 0, and I can do printf, something like this, hello world, /n, and I also have to provide a null terminator, otherwise it's not going to work. All right, so let's actually also create make files. All right, so and in here we depend on O. And what do we do with that O? So where is the make file from the Crust? So this is how we sort of link everything together, right? So we include debug information. This is very important. We optimize, so it optimizes the size of the executable. I don't really know why without this thing it just doesn't work. It cannot find certain things from the core, right? So instead of compiling the final executable, we're emitting the object, right? And we're setting the style of panic as a board. Right, so, and this is actually needed to create the O file from RS. Right, okay, so that's fine. So to create the final sort of, you know, executable, we have to link all of that together. Right, so we provide the name of the final executable. This has to be actually tab. So here we're just linking with raylib. I don't think we need a linkage with the raylib, and I also don't think we need a linkage with the math library, right? So then we just linking that O file into a final executable. So that's basically what we're doing in here. That's how you enable Crust. And there you go. It doesn't fucking work because why? So because on top of just enabling some things, you also have to say things like, I suppose, no main and no std, right? So that's the things you have to provide in here. And main, so core resolved. Okay, so let me see what we have to do in Crust. I think I forgot to provide some things. You have to put exclamation mark in here. So I don't remember. So I think it's needed. So it's for the entirety of the crate or something. I do not quite remember, chat. I do not quite remember. Okay, so you also have to provide the panic handler, right? So without the panic handler, it cannot do shit. Okay, so can I just build it now? All right, so you need the panic info. Without the panic info, you can't define the panic handler. Without panic handler, you cannot do shit. Finally, we compile this piece of shit. Holy fuck. Right, so it has a bunch of warnings, right? But I think that's totally fine. We can maybe just allow that code or whatnot, but let's not do that for now. So if I do a main, something like this, it says hello world, as you can see. Right. So maybe we need to create some sort of a template so it's easier to start programming in Crust, right? So because as you can see, you need to do a lot of like annoying things, right? So, but that's the price of Crust. That's the price of Crust. The price that you pay for actually usable language. Okay, so now we need to read the contents of the main RS. So I want to have a function that is something like a read entire file from knob, right? So in knob.h we have a pretty cool thing called the read entire file. So yeah, and it accepts the path to the file, and then the string builder, and it actually basically populates the string builder. Then it contains the content of this entire thing, and you can just like do something with that content. I can try to port this function, or I can try to maybe link with that function in Crust. That sounds like a cool idea. Right, so let's actually give it a try. So maybe we want to try to do that. All right, so let me maybe fetch the latest changes from knob, because we've done a lot of changes since the last stream. So let me actually merge everything in here. So, and yeah, that's quite a few changes. So I suppose they still compile, right? So everything is supposed to still compile. All right, so all of the tests running correctly. So that's totally fine. All right, so I suppose what we have to do now, we have to copy paste knob.h. I'm copy pasting it in here. So we can't use the C code in Crust directly, unfortunately. But we can try to compile this entire thing into O file. Right, and then just link with that O file and have a little bit of bindings and stuff like that. Knob.rs, right? So nob.rest. That's exactly what we're going to be doing in here, nob.rest. But the first thing we need to do, I suppose we need to create an O file out of nob, right? So I want to have nob.o, and obviously it depends on nob.h. So the thing about nob.h is that if you include it by default, it's going to act like a C, like a H file, right? So it doesn't contain implementations. So to make it contain implementations, you have to define nob implementation macros. So essentially to compile it, what you have to do, you have to, try to compile it, and then you have to say nob implementation, right, like this. But the problem with GCC is that it detects the language by the extension, right? So it will think that you're trying to compile precompiled headers. So you have to explicitly say that we're compiling C file, right? And that's how you do that actually. So let me actually try to do that. So make nob.o. And it complains that it's undefined main because it tried to create a final executable out of that. We need to have an equivalent of emit object, but for C, and that equivalent is just -c, if I remember correctly. And there we go. We finally managed to create an O file, right? So, and it's 38 kilobytes. It contains all of these implementations, right, in an object file like this. So, and that means that we should be able to finally link this final thing in a final executable like so, right? So now when I try to build this entire thing, it actually links the nob in here. And that means that we should be able to maybe create some sort of a module called nob, right? And within the nob, we can try to have read entire file. So let me see, read entire file. So this is a write entire file, a read entire file. So here it is. So to have this kind of thing, we also need to have the definition of a string builder. So look, we have a lot of prefixes. We have a lot of prefixes for like nob underscore and stuff like that. And we have them because we don't have namespacing in C. But we do have namespacing in Crust because Crust is obviously better language than C. So that means we don't have any of these things in here, right? Because every time we access them, we can actually access them as nob : read entire file, which is basically equivalent to that, but actually better, right? It's just semantically better. In the sense that you can always do something like use and you can just drop this entire thing. So you see, mechanism of dropping and stripping the prefixes is built into the language. Think about that. Think about that, chat. That's pretty fucking epic. So now let's actually put this entire thing in here because that's how we're supposed to create structures. So items, this has to be a mutable pointer, right? So a mutable pointer to a character, and let's maybe make it U8 instead, right? So this is going to be U8. Maybe I can use a little bit of a Emacs magic, right? So this is U size. Then I on all of them, and there we go. This is what we have, and on top of that, as far as I know, we have to use colons instead of commas instead of semicolons. All right, so this is the string builder, but on top of that, we have to actually say that representation of this thing is a C representation, right? So it packs it like a C structure. Okay, so here is the fn, and it's an external function, and it's supposed to return a Boolean. So what it accepts in here, it accepts the path, which is a constant pointer to U8, right? So the usual thing in here. NSB is actually a mutable pointer to string builder defined in here. That's what we have in here. So we also probably need some sort of a way to define an empty string builder. So we'll probably have to implement something like this, right? So here is an empty string builder. Does it need generics? I don't think it needs generics. So we need some sort of a constructor in here that returns self. So and self here is actually items, ptr null, probably mutable, right? So this is how we define null in here. So count is going to be 0 and capacity is also going to be 0. String builder, by the way, is a dynamic array for those who didn't know. Anyways, so that should be it, honestly. We can try to now compile the whole thing, and obviously it wants core ptr, right? So let's actually do use core ptr, like so. Is it going to work? And this thing, it wants a body, because I forgot to say that this entire thing has to be external C, right? So because we're trying to link with external C code. That's what we're trying to do, and as you can see, it does in fact compile. So let's try to read the the entirety of the file in here. Can we do that? We can
do something like knob read entire file like this, right? So we have to put a null terminator in here because Crust doesn't do that out automatically for you. So we have to treat it as a pointer. Then we have to allocate this string builder on the stack somewhere, right? So string builder SB. In fact, we can just do something like new right away, and here's SB. So, and it has to be mutable. It has to be mutable. And then here we take a mutable pointer in here. As far as I know, we have to also do row, but I mean, it's kind of a new feature. So let's not do that. And here's the thing. If this thing returns false, that means we did a fucky wacky. We failed. We couldn't read the file. So what we have to do in this situation is just return non-zero exit code. That's it. So after that, we can declare that the file was successfully, read. I forgot the past of the word read. So what we can do in here, we can now print the size of the file, right? So size of file is something like this, where we specify SB count. So, and let's try to compile this entire thing now. So string builder is, so we need to make all of these things public. I completely forgot about that because Rust being anal like that, it's always been anal like that. You have to make all of these things public. Right, so this is going to be pub. All right, let's go. And what does it say? Undefined ref. Okay, so here's the thing. So the actual name of the function is not read entire file. The actual name of the function is knob read the entire file, right? So we have to take that into account. And as far as I know, it's pretty easy. You can just specify the link name through this attribute. So let's put this thing in here, and this thing should be just like this. All right. So, and it compiles. Not making anything up, it straight up compiles. So, and then I can do main, and it read 88 bytes. Right, if I take a look at the size of node B, it's in fact 88 bytes, so precisely. So now, right, we want to actually print the content of the file. So let's actually see how we can do that. I think the easiest way to print the content of the file is fwrite, but we need to create like a bindings for this function. It's a little bit annoying. And by the way, unsafe Rust doesn't have restrict words, right? So because it's a pretty unsafe language, I gotta tell you. It's a pretty unsafe language, but anyway, and also we need to have like a pointer to, stream if we want to actually print properly. Damn, that sucks a little bit. That actually sucks. But one of the things we can do, as far as I know, we can just like use printf, something like that, and we have to provide either like this or either like this. I don't remember, like I can never remember like where you have to put dot and star, but this is something that we can try. So I have to do count. And it has to be, by the way, I32. That's very important. And then here we provide the items, and that's what we can do in here, hoping that it will print the content of this thing correctly. So let's actually do make -b, and as you can see, it actually successfully printed the content of the file. Right, so we just used knob in Crust to read the content of the entirety of the file. So again, Crust is actually a pretty cool language. You can just directly use C code from Crust, even if it's a header-only file. Right, you just have to compile it in a very specific way, right? So you have to compile it in a very specific way, but I mean, you still can use that. So that means like we can use stb image, right, to do some things. Like we can do a lot of stuff in here, just in Crust. Absolute coding, absolute fucking coding indeed, right? So coding in the chat, everyone, coding in the chat. So that's actually super cool. So let's continue, I suppose. Let's continue. Honestly, I would love to maybe rename the whole thing to something else, right? So currently it's called main, but this is, so it's kind of, the name of the compiler should be different, right? So let's actually maybe call it B, right? So, and the name of the executable that does the B compilation, if I understand correctly, it has to be B, right? So there was a B computer language, so there was some sort of a man page, or at least down there. So man page, I can't really find that man page B, but I think I remember that it was actually just the B command, right? So I think I will remember that it was just B command, and let's actually like continue that sort of tradition. So this is going to be B, so BO, 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 and this is B. So, but for the rest of the things, we're going to call them as usual. Right, so if I try to build the whole thing, right, it's build the final B executable, and if you try to do B, it actually read the entirety of the source code, and here is the B program. So, okay, then the next step in, I suppose, compilation of the B program would be to tokenize it, right? So it's always the first step in compilation of any programming language. So we can try to use stbclexa, right? So I said multiple times that if I try to use stbclexa, please tell me not to do that. But I actually recently tried to use stbclexa in my private project, and I think I figured out more or less the way how to properly use it. So I think I want to give it a try one more time. I think, okay, look, I think I want to, okay, it's so over, yeah, so I'm probably going to waste a lot of time, but I mean, please. But again, I used it recently in my private project. Chat, listen. I tried to use it in my private project, and I think I figured it out. I think I figured it. Alexa, I want to use stbclexa. I want to use stbclexa. You have Alexa. It's not exactly so. The thing about Alexa is that you need to customize it first before it can do what you want. stbclexa already supports all of the things, right? So stblexa. Okay, let's give it a try. Okay, so if I start to sort of like get sucked into the tar pit, we can always switch to Alexa. Okay, so let's just give it a try at least. I just want to give it a try. Look, it's gonna work out this time. I swear, it's gonna work out this time. stbclexa. Okay. Yeah, I have a Stockholm syndrome. That's true. That is true, actually. Okay, so let's download this entire thing. Right, so let's fucking go. Yeah, I can stop at any time. Okay, I can stop at any time. Now let's do this kind of thing. stbclexa. And here stbclexa implementation. So let's give it a try. I'm gonna just do boom. And did it create? Yeah, so this seems to be like the final thing that we need in here. That's pretty cool. And in a makefile, we are linking the compiler with this thing. So I'm gonna do -b. There we go. We got a final compiler, and we link with all of these things in here. Cool. So I suppose now in the B compiler, we need a module that is responsible for stbclexa. stbclexa. It's kind of cool. Here's the knob. Here we're going to have stbclexa. Here is the libc, right? So all of the necessary libraries, like all of the libraries are here. It's pretty comfortable. And without cargo, by the way. Like I'm not using any cargo or anything. It's just like, yeah. We can have another layer of this thing, stb, right? So, but I don't feel like I want to do that. We could, but I mean, why? Right. So where is the stblexa? Okay, so here it is, and yeah, that's a lot of things. Well, not that many, honestly, not that many. So I think we can live with that. So I'm gonna copy paste this entire stuff like so, and so let's actually bring this stuff in here. So this is a char, and this is the integer, and so on and so forth. For all of that stuff, we'll probably need to have an FFI. An FFI. By the way, I think instead of use size, I probably should use, size t from FFI. I do not quite remember. So rust up doc. Let me find this entire thing, and it's just going to be FFI. So where is the FFI? Do you have something related to size? I actually don't see it. So there is no C size or anything. Straight up. So C size. There is C size T, and it's exactly in core, actually. That's very interesting. So that means in here, we should have actually used C size T. Right. So let me see. C size T. So this is going to be use core FFI C size T. C size 2. So I have to put additional colon in here. And in here we also have to do this kind of thing. So in terms of char, so there is some sort of weird discrepancy between like C char and the literals that are used in Rust. So it's kind of sus, honestly. It's a little bit sus. So this is because they probably expect you to use their C string thingy or whatnot. But I'm not sure if I can use CSTR from core. Right, I mean, FFI, there is a FFI core, so that means I probably can use this kind of thing. So here is the pointer, so I can create this. Like, this is a little bit complicated, right? So I don't really like how freaking complicated all of that stuff is, but I mean, it is what it is, and it isn't what it isn't, right? So I like simplicity. They like complexity, obviously. We're not the same. We're not the same, chat. Okay, so here's the input string, and this is supposed to be like a mutable U8. And I wonder if I can just quickly do some stuff like that and just, you know, mute U8 and maybe align this entire stuff by a colon. Look at that. Doesn't that look cool? C-star is in core, C-string is in alloc. Like, is there any way, like, if I could just, well, I mean, I can do something like this, can't I? I can't do this kind of stuff. It's just in a different edition of Rust. Fuck. Okay, let's give it a try. Let's give a try to that stupid ass edition where we have this. Okay. Let's give it a try. Right, so this stuff, where are the errors? So here, use unstable, and this thing is unstable library. Fuck you. Why I'm so tired of ranting about that. It's like insane. Like, why this kind of thing isn't freaking nightly out of things? This language is 13 years old. 13 years. When you gonna fucking finish your language? So, like, Rust was developed by Mozilla, right? This is what sucking on Google's money do to you instead of making them yourself. Right, like, when you don't rely on actually making something valuable for the market and only rely on some big daddy Google giving you money, that's the fucking result. 13 fucking years. Size T is an unstable feature. Holy shit. Sure, kurva. I'm sorry. That's a good question. I approve of that question. I have the same question actually. So, anyways, let's actually try that stupid ass edition. Rust C help. So what do we got? Edition. Ooh. Maybe we should jump straight into 2024. That woke up grammar, I'm so sorry. So 2024. So is 2024 better than 2021? What do you guys think? 2024 is tomorrow. Dude. Bad news for you. Anyways, so let's give it a try. So I suspect it's not gonna even compile. 2024. Let's go. Boom. Oh shit! Of course it didn't fucking compile. External blocks must be unsafe. Is that what you wasted Google's money on? Really? Really? Is that what you wasted Google's money on? Well, unsafe attributes. Okay, so there is an error. Yeah, and even after that, this stupid ass thing is still okay, it's still unightly. Alright, so use size. I'm gonna use use size in here. So any errors or only warnings, right? So unused import. It's kind of funny that I can import it, but I can't really use it. Okay. So that seems to be working. That seems to be working. So, and now here is the moment of juice. Orange juice. So, okay, that kind of worked. But at the same time, yeah. But I mean, it's actually kind of fine. So that just means that I can replace all of these U8s with C-char. Right, so I can replace them with C-char and it's gonna be totally fine. So let me actually do something like C-char. And I'm gonna query replace U8 with C-char. Boom, boom, boom. And, well, obviously in here and in here as well. So, and I don't even have to do it like that, don't I? Right, so it complains about, yeah, so it's a mutable C-char. Where is the FFI? Give me FFI. Yeah, use score. Let's put that stuff in here. So, so also that stuff goes to here. C-char, and that stuff also should go somewhere here. Right, so we have to use it everywhere. C void, C is too many like stupid fucking warnings, honestly. Oh, this one is interesting. So the type of this thing is straight up sister. Okay, that's even better, I think. Right, so that means all of these things I should be C-char. So I should do something like mute C-char. Oh, and it's a freaking rep. We can't afford that. It's a freaking reference. We can't do that, Dave. We can't. Like, this is against, like, we just can't. No, we can't do that. We have to do SPTR. I'm sorry. Rules are the rules. I didn't make the rules. Actually, I did. But anyway, I didn't make the rules, so we're following the rules. So, what do we have? Okay, so what we have here is, yep. And we also have to, this one is interesting. So in printf though, yeah, so this one also has to be something like this. Finally, it compiled. Hell yeah. So finally it compiled, and it kind of works exactly as we need it to. Really like that, really like that. So, yep. So now let's go ahead and just do this kind of thing. This one is cint. This one is a bunch of chars. Emacs, can you just freaking work? Mute C-char. And this one, mute C-char. All right. And here's the long. Do we have C-long? Shlong. Long, shlong. So that means I should be able to do something like C-long. And this one is le token. And this is le double. Do we have a C double? Do we have C double? C double. Yeah, we do. Look at that. We do in fact have C double. So int number C double. And this one is immutable to C-char. And this one is C-int. That's cool. So let's actually import all of these things. C-long, shlong, C-double, and C-int. I think that's everything. So this is basically this the definition of the Lexa. And we also probably do have to do wrapper C, like so. And boom, does it compile? Doesn't even fucking compile, because all of that have to be commas, not semicolons. All right, it compiles. Right, so we just redefine the structure like that. Cool. And another interesting and quite important thing, I think, is the initialization of the Lexa, right? So this is very important function that we have to put in here. And of course, it has to be unsafe. Extern C, because that's not enough unsafe keywords, apparently, right? So here's the Lexa, and it's a mutable pointer to the Lexa. So here's the const char. Okay, that's understandable. So this is a const C char. cool. This one is a const cchar. This one is not const one. This is a mutable one. Right, so this is a mutable cchar, and this one is just a storage length. It's the cint. It doesn't really return anything, does it? Okay, so it doesn't return. All right, so and now I should be able to do some scheisse. Like for example, I have SB, and here I also allocate the lexa. Right. So to allocate this entire thing, so I remember there was a zeroed, right? Somebody suggested zeroed, and I kind of dismissed it, but we dismissed it because we didn't initialize C runtime correctly. I think we should use zeroed everywhere in here. So it's a, yeah, so it's probably in core mem. Right, so let's do core mem zeroed, like this. So that means I should be able to define something like stb C lexa, and it's a little bit of annoying because we have a prefix stb C lexa, and then I have to do stb lexa yet again. So maybe I should actually strip off all of these prefixes somehow, but we'll see. Right, so what I have to do is just like a zeroed, like this, and that should work, I think. So let me try to compile it, and you expected this thing, so you want me to do it like that? Couldn't you freaking Brovsky figure that out from this type? Or do you really want me to explicitly put it somewhere here for you because you're incapable of figuring it all out? Ah, I'm an idiot. I'm a dummy dum dum. I'm sorry. That's fine. So what you have in here? So this one is just that stuff. What else do we have in here? STB, oh, it's all private. Of course. Do Rust developers really get a kick out of being so anally fucked all the time by the compiler? Do they really fucking enjoy that? How is that enjoyable? I don't fucking know. I'm sorry. Yes, I do. Ah, okay. I mean, I don't kink shame. It's just like, you do you. You do you. Anyway, so... Alright, that seems to be working. So that means if we're gonna be using like a zeroed, maybe we don't even need the constructors anymore. Chat. That is actually freaking poggers, I think. So look at that. I can just do something like that, and then I can say zeroed, like this. And where is the implementation for the string buffer? And we can nuke this entire thing. Boom, and that works. All right, so we did that, and then I have to now finally initialize this entire thing. So this is going to be stbc lexa. Right, so and then we have to take this entire function like this. I'm gonna put it in here, and now I have to just provide the pointer to this thing, right? So this is the pointer to just L. Input stream, this one is interesting. Input stream is SB items, right? It is straight up SB items, and then we have to provide the end of the input stream. But luckily, it's actually super easy. It's SB items, and then we add SB count, the entirety of the size, and that points at the end of this thing. So we need to have some sort of a storage in here, but that means I just have to allocate it somewhere. Let's not allocate any storage yet. Do we need it? Yeah, we need it for the identifiers. Actually, we need it for the identifiers. So, and now I need to put a null in here. So it's going to be ptr null mutable, and the size in here, let's put 0. Right. So I'm going to actually add the storage a little bit later. So let's actually see if it compiles. Right. Obviously, it doesn't compile right away because we need to have this use core ptr, otherwise it's not going to work. And it seems to be compiling. Right. So we successfully initialized this entire thing. By the way, it will be kind of interesting to see if we actually go into the initialization function. So one thing I want to do, I want to enable debug information for all of these things, right? So let's do ggdb, and maybe GGDB in here as well, and let's just do like full recompilation. Right, and now I should be able to do something like this, where I break at main and just run this entire thing, and we can't see shit, honestly. So I wanted to break at main, right, and did it crash? I didn't think so, actually. Right, so we can try to, yeah, there we go. So we're sort of stepping through this entire thing, and now we can go to STB. And here is initialization. I'm going to break at that specific initialization, and I'm going to continue. And it doesn't update properly. Something is broken, but at least from what I can see in here, it's actually stopped at STB Selector init. So something is broken with GF2. But instead of GF2, we can actually use maybe GDB instead, right? So because GF is kind of broken. Especially with Rust, right? So Rust has its own custom Predi printers shipping with the executable and stuff like that. So I don't really know what's going on there. So let's do that. Let's maybe break at what was that? This function break at that specific function. It actually found that function. That's pretty cool. Let's run this entire thing. I can do TUI enable. We can't see the source code, unfortunately. I don't really know why though. So didn't really like that. Kind of didn't like that, but I suppose it kind of worked, right? So it kind of worked. Right, we can't really see that. So it's pretty cool. So we should be able to now maybe try to iterate through all of this thing, but we also need to allocate like a storage for the, what is it called? The string literals and stuff like that. No GGB for STB. Maybe this is because of the GGDB. We can try to get rid of that, so just G, because just G should also work, because in Rust we use just G, so I don't really know. We can give it a try. Okay, so it's kind of a different thing now. I'm gonna do GF2, break at main, run, and same shit, honestly, same shit, right? So it didn't work properly, but anyway, okay. So now let me actually acknowledge the subs, right? So because people have been subscribing and I was kind of neglecting that. So let me see what we've got. Where did I stop? So Branch Wag, thank you so much for your own with the message. Sub anniversary, woo, you always motivate me to code. I'm really glad to hear it, thank you. So Code Penny, thank you so much for your own with the message. My lucky number. 13 indeed. The Rugged Bear, thank you so much for your own with the message. Heart indeed. Mad Eye, thank you so much for trying with the message. Thanks for the content and have a great day. Have a great day to you too as well. So Anonymous Gifter, thank you for gifting the subs. Daruk Sega, thank you so much for the prime. And Bash Erper, thank you so much for tier 1. Thank you. All right. So to iterate through all of these things, we need to have this function actually. So let's go. Let's just define this specific function in here. So it's going to be public fn. It returns cint and it accepts the mutable pointer to this entire thing, and that's it. So we already have this function defined. The thing about this stuff is that it returns non-zero if a token is parsed or 0 if it's end of file, which makes it rather easy to do something like this while stbc lexa get token, right? And probably we could drop these prefixes, right? So lexa, maybe just like init get token, right? So because we already have stb lexa, yeah, so we probably could drop these kind of things, but we'll see. So get token, we provide the mutable reference to L, and while it's not equal to 0, we just iterate and print the current token. So that's what we're going to be doing in here. So I can even put this stuff in here. Right, so this one is more like a D, and what I put in here is in fact so lexa token. So that's what it should be, right? So let's rebuild this entire thing, and I forgot new line. That's totally fine. Maybe. All right, and that's the things we've got. If I remember correctly about stb selector, right? If L token is less than 255, that means it's kind of ASCII, right? So less than 256 actually. So and in that case specifically, we have to treat it as a character. Otherwise, we can treat it as something else, right? So that's basically what's going on in here. And we've got all of these things in here. So 257, if I remember correctly, 257 is Lexer ID. So it's a Clex ID. We can take a look at this stuff. So there's no, yeah, it's not direct, but it's a Clex, Lex ID. Yeah. 256, it's the end of file. 257, parse error, really? You telling me it's a parse error? I know why. Because we don't have a storage for string literals, right? So let's allocate some storage, I suppose. Okay, so let me find, so yeah, it's a string store. How can we do that? I suppose we can just do something like a string store, and this is supposed to be an array of 228 of C chars, right? So that's what we have to do. And we have FFI, yeah, we do have C chars, so that's totally fine. And in here, all right, when I define this entire thing, I suppose I can do string store as ptr, and then here I can do string store len, and that should be enough, right? So if I try to run this entire stuff, it doesn't work. Because why? I suppose it has to be the other way around. I can never remember in which order all that stuff has to go. Well, I mean, nobody cares. Show me the error, please. Where's the error? So the arguments of function are incorrect. Expected I32, but found use size. Okay, as I32. Anything else? What's the other error? Types mutability. So as pointer returns your const. So show me what you got. So that means there should be as ptr mutable. Yeah, boy. Wait, no. What the fuck? As ptr. So we have slice as mute ptr. Okay. So where is the as mute ptr? What's the other error in here? String store here is used but isn't initialized. Fuck you, Leatherman. Fuck you, zeroed. Fucking zeroed. Zero yet. Yo, motherfucker, yo. 260. 260. Look at that. 56, 57, 58, 59, 60. It's a Clex ID. Identifier. Okay, sorry. Yeah, so and that identifier should be stored essentially in a string storage, but I don't quite remember. So in a structure, I think it's located in here, straight up in string. So let me see. I can do something like if equal to 260, right? So it's just a 60. Where is the compilation? Yeah, it's 60. So what we can do in here is just like treat it as s, and this is a string, right? So in here we can just do Clex ID like so. Look at that. 258. I don't quite remember what it is. 258. So it has to be this. So it's a cint literal. It's secret literal, so that means it should be relatively easy to actually pick it up. So else if L token 258, that's a little bit not what I want. Int lit d, and then what's the? It's just the int number. Okay, so int number. So let's rebuild everything. It doesn't rebuild. Why? Where are the errors? I didn't see the freaking errors. What do you want from me? L real, because it's that. Okay. We tokenize the entire source code. Tokenize the entire source code in Crust, by the way. Just hack together a bunch of libraries, right? So nob and stb selector, and it's actually kind of pleasant. It's actually kind of pleasant. Like, and honestly, it doesn't matter how much Rusticians are trying to make it uncomfortable. It's still better than Rust.
honestly, like, it doesn't matter. You can like mandate to put even more unsafe in here. This is pleasant to use, no matter what. I'm sorry, you lost. Rusticians, you lost. It's still convenient. Just like, you can double the amount of words unsafe. It doesn't fucking matter. We know the truth. We know that you're trying to hide this beautiful, beautiful language under this like safety agenda. Look at that beauty. All right, so yeah, now we can make a pass, and it took us like 1 hour. It didn't take us too long, right? So that's actually pretty straightforward. Let's look how productive you can become if you just like, you know, embrace the unsafe. So yesu. I kind of want to get rid of these prefixes. So let's do the following thing. So link name, I'm gonna put it in here, and this one is gonna be just init. And in here we can do get token. So and then there's just something like this about that. So that way you don't have to add this additional prefix. So you can just do stblexa init. You can just initialize that. By the way, we're using like a recent edition of the of Rust. So that means we can have methods that accept self by a pointer. We should give it a freaking try, because that way maybe we can make get token. Can you have extern C functions that are methods? Well, you probably have to do a wrapper, but I mean, I don't know. It's kind of too much craft for such a simple thing. But anyway, so let's actually try to do that. Let me do a make -b. Yeah, there we go. So it's pretty cool. All right, we can read the file. We probably should accept the pass to the file through the command line arguments, but I think it's just a waste of time, all right? So it doesn't get us closer to the future. It doesn't really get us closer to the future. Right, let's make a small break. I'm gonna make a cup of tea, and after I make a cup of tea, we're gonna see how we can approach actually translating this very simple source code to, I suppose, assembly, right? So what I want to do in here is just like I want to generate FASM, right? So my usual thing, my usual backend for all of my languages, because it's so freaking simple. I love it. Right, so let's just give it a try. Right, let's make some mic and all right, so we're back. We gonna be generating FASM, right? So that's basically the idea. We're gonna be generating FASM, and I need to remember how to generate programs in FASM. So let's quickly try to do that. Main ASM. So I don't remember. I think it was like format. Yeah. Okay. So it highlights that ELF64 executable. I think I kind of roughly remember it was something like that. So we can do start, and in here we can just put return. So let's actually see if it's going to work. So maybe I'm gonna just do it as a test, right? So it's a test ASM. So let's include the test ASM into here, right? So this is gonna be test ASM, and just do FASM test ASM, right? So that's what it is. And let's actually specifically build test.o, and we managed to do that. So oh, it's straight to build the final executable. Okay, so that makes sense. So, but we are going to be linking with external functions. That's what we're going to be doing, because we do put char. So that means we have to do a little bit of a different approach. So, and this is the approach that I think I did in my Russian programming language. I'm bringing it up over and over again because I think I did a pretty good research in there on like how to use FASM for linking stuff and stuff like that. So I'm gonna put that in the description, right? So because it's part of the references essentially, right? So it's part of my ongoing research in programming languages, even though it's kind of lame compared to what people
who actually work in developing languages do. But anyway, it's my personal research, right? So I intentionally don't read any materials on how to properly make programming languages because I kind of want to discover this proper way of doing things. You know what I mean? 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 So it's just format ELF64. Okay, so what's funny is that it depends on the mode. I remember I had a mode for static linking, right? So it says статический, which means static. And there's also dynamic one, right? So, and if you're using dynamic one, you're supposed to use different sections. Okay, so I'm going to refer to this file. I'm going to be referring to these files specifically. So it's just a format 64. And now let's remove the executable and try to make this thing. And it created O. Right, so depending on what you put in here, either an executable or not executable, it's either going to create a final executable or an O file. So that's what's interesting in here. Right, so if you just do that, it creates an O file. And now the next step in here is going to be linking that file. So let's do something like this, test O, and let's do LD test O. So let's try to now just build the final executable, and it cannot find the symbol start even though we declare that symbol. As far as I know, this is because it's not public. You have to declare it as public. So this is just off the top of my head what I remember about this entire thing. Okay, so, and as you can see, it linked successfully, and now we have a test, and it's linked with additional runtime, so it's a 4.5K or whatever. What's interesting is that we having the same kind of situations as we had with Crust. We don't have C runtime. I think it would make sense to actually link with the C runtime, which is kind of ironic for a B program, don't you think? So B program is going to be using a C runtime. But I mean, this is because I suppose C runtime kind of inherited a lot of stuff from B, right? So for example, function putchar, right? So in this example, they actively use function putchar, and it actually survived to this day, right? It survived to this day. It exists in a C runtime. So Rust uses C runtime too. I suppose, yeah, so I think there's nothing wrong for a B program to use C runtime. And because of that, what we have to be doing actually, we have to replace start with main, right? So this is now a main, and we should in a make file, we just do FOSM, but as we link it, we should link with GCC, like so. I think that's what we're going to be doing here. So, and it works. So because now, and as you can see, it actually linked it with a lot of shit. Right, so it links it with libc runtime. If I try to just run this entire thing, it's not going to work. And this is because at the end of the execution, you have to... Oh, this one is interesting, actually. Wait a second. Returning from main should actually exit correctly. Aha. So that means, like, we don't have to call syscalls directly. We can now call functions from libc. But on top of that, libc runtime expects main to return the exit code. And according to Linux x86-64 ABI, functions return through rex. So now, if we do something like move rex 69, this is going to be the exit code of this program. Absolute coding. So that's actually pretty straightforward, right? Remember all of these examples where I did like a, exit syscall and then write syscall and stuff like that. If you link with C runtime, you don't really have to do any of this shit, all right? So you can just work with all of that stuff directly. In fact, right, so we can probably do something like putchar, right? Funnily enough, by the way, to declare an external symbol in FOSM, you use a keyword extern without E, literally like in B. I never made an association. I wonder if Tomasz Grisztor, the author of FOSM, actually made a reference to B programming language. Is that a reference to B programming language? Does anybody know? It's all connected. I wonder. So I wouldn't be surprised. It's just a standard Unix file. Ah, okay. Very well then. But I mean, what's interesting is that there's so much actually uses Windows. He's more of a Windows developer, and FASM is kind of like built around the Windows environment. So I don't know, is it really Unix or whatever. Anyway, so we can do putchar, but I don't remember the call convention for regular functions in Linux. x86, yeah, there we go. It's a call conventions for, so call conventions x86, 64, not syscall specifically. Calling conventions, Microsoft, who cares about Microsoft System, the AMD ABI? Why do you have a wall of text in here instead of just a plain freaking list of the registers? Oh, here, just remove the RDI. Okay, so first six are used for these kind of things, but is it syscalls? Because I remember that for syscalls, it's kind of different. All right, so let's give it a try then. One of the things we can do in here is just like a move RDI 69, and then we can call putchar. So that should be it, actually, believe it or not. That should be it. And putchar causes overflow. That's unexpected. How am I supposed to even then use this entire thing? Linker fun, exactly. Linker far. Yeah. So what's up with this function? Wait. Putchar. How am I supposed to even use this thing then? Because it's a kind of a simple function. Right, so, and I would just expect it, yeah, just like use this function. So what's up with that? Why can't you just call this thing? I don't even know how to proceed. It's just like, it's so stupid. Let's see, maybe we saw something like that. Okay, NASM simple, yeah, okay. So people experience something like that in NASM at least. So let me see. Shut the fuck up, Google. Nobody gives a shit. Try compiling with no PIE. But PLT. What at PLT? Or does it have to be... Do I really have to be doing it like that? What does it mean actually? It's undefined. Like I don't know what you're talking about. So, and especially you just ask the question, what exactly do you want me to do with this name? Where do you exactly do you expect me to put it? Like I don't get it. So what do you mean? I don't know the FASM syntax for that, but what is that? What is that at PLT? Like what is that exactly? So what exactly are you talking about? Like I kind of vaguely remember static and dynamic linking, what's needed for PLT. So you're talking about something which I kind of vaguely remember, procedure linking table. Okay. Okay, so this is kind of interesting. FASM procedure linking table. Right. So, and people are okay, we're getting somewhere. Thank you so much. Procedure linking linkage table. Ooh, holy shit. Fuck, I lost it. All right. So, thank you so much. It's something useful. So executable linkable format. To select ELF output format, use format ELF directive. The default code setting for 32, blah, 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 but 64, blah, 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 blah. Okay, cool. Ooh, I forgot about the sections. Right. I literally forgot about the sections. I think one of the things I have to do in here is also specify the section, because this is something that we did in the programming language in here, right? So there was a section like a text executable and stuff like that. So I completely forgot about it though. So, and maybe this is where I have to do this kind of thing. And also the extern stuff worked. Extern. And we did that actually after I did public start, I just like specified all of the external symbols in here. Please forgive me that it's all in Russian. That was kind of part of the joke. So, and I suppose maybe that is going to work if I try to do it like that. Well, I mean, of course, you don't need to escape it in here, obviously. Oh, okay, so this is different, at least now. Relocating against put char in read the text, relocating against symbol cannot be used when making a PIE object recompile with FPA, but we can't recompile with FPA because FASM doesn't allow you to do that, right? But there's something in documentation in here which could be useful for us. Section directive defines a new section. It should be followed by quoted string defining the name of the section, right? In our case, it's actually .text. This is where we store the kind of thing. You think it has to be done on the linked stage? You think it's on the linked stage because they say compile it, not link it? Or you mean no PIE? Okay, that's fair enough. Why doesn't it suggest instead no PIE? No PIE. Okay, thank you. Thank you, Agilcaro. So I think I should give you VIP to both of you, by the way. So VIP Agilcaro, it's your VIP now, and Rutifant as well, because you just actually taught me something, right? So I think I'll need to look into that a little bit deeper. Right. So the problem with the position independent code is that it's such a kind of a lost information over many years of programming and many layers, right? It's so hidden behind because it's a concept that only makes sense in assembly when you're programming directly in assembly, but very few people still program in assembly, right? But since all of the abstractions are very much leaky, that concept still leaks through, but nobody fucking remembers it. So, and it's kind of difficult sometimes to find any information about that. So thank you so much. And I suppose this problem will become even worse as the next layer of the abstraction is going to be natural language that generates code through LLMs, right? So a lot of concepts in actual programming below a prompt are going to be forgotten, but since the abstractions are leaky, they're going to be leaking through the prompt and nobody will fucking know like how to fix problems related to that. We already kind of feel sort of kind of similar things in here with assembly, right? So that concept only makes sense within assembly, but nobody programs in assembly. So how the fuck do we solve problems in here? So yeah, it's kind of interesting. I kind of want to read more about this thing, right? So because I'm kind of curious about this stuff. So it also talks about PLT and everything. Okay, so section directive, right, defines a section and stuff like that. Optionally, also align operator followed by the number specifying alignment for the section. I don't think we need alignment in here. External and public directives have the same meaning and syntax as when the COF output format is selected, right? So we don't really work with that format, so whatever. The RBA operator can be used also in a case of this format, however, not when target architecture is x86-64, and that's our target architecture. So it converts the address into the offset relative to the GOT table. I don't know what is a GOT table. Global offset table, I suppose. This is my best guess. What it is. So it may be used to create position-independent code. Ooh, that's interesting. There's also a special PLT operator which allows to call external functions through the procedure linkage table. You can even create an alias for external functions that will make it always be callable through PLT with the code like this. Okay. Let's give it a try. So we have extern printf as this thing, and then when we're referring to this one, we refer through PLT, but let's actually don't do that. Let's do put char. And now if I do make file, let's remove this thing. That also works. So if you want to have position independent code, that's how you have to actually declare external symbols in FASM. So yeah, this was a collaborative effort of figuring that out. So that's so cool. I didn't know that. Okay, so I'll definitely have to read more on this kind of stuff. I definitely have to. I wonder if I can give a link specifically to this section. Does this section have an ID? Yes, it does. You know what that means? I can copy this ID and I can actually put it as an anchor in here. And now I can refer to that. Yeah, so I can actually give a direct link to this specific thing. Right, so I'm gonna put it in here like so. And maybe I'm gonna also put it in the description in the references. Look at that. So because sometimes some websites don't provide you the sort of anchor link, but if any element on the page has ID, it is already usable as an anchor. So you can sort of like hack it together and like refer to it like that, even if the page directly doesn't support that. So yeah, lit HTML, yeah. That's pretty cool. That's pretty cool. That's pretty cool. So yeah, so we have two options. We can either do that through PLT, or we can not use position independent code. So, but let's actually use PLT, because why not? Why not? Why not? And now, okay, so it seems to be working. It seems to be working. And here is the thing. We are printing a character with the ASCII code 69. Let's actually take a look at the ASCII table. So here's the ASCII table. And what is the character that has a code S69? Let's take a look at that. It's E. So if we see E after running this program, that means we did everything correctly. So yeah, we just linked with the C runtime and we called a libc function through this thing. Forcing E. I see bytes. Cool. So I guess that's everything. So what we have to do now, is take this file, right? Take this file and generate this kind of code out of this file. That's basically the idea in here. So the question is, how are we going to be generating like automatic stuff in here? That's a good question. In fact, that's a good question. But to be fair, you know, maybe going with the position independent code is a little bit better because it simplifies the generation of the code. Right, so no PIE. Yeah, because now every time I encounter the external symbol, I can just generate this thing. You know what I mean? Like I can just do that. No pi, yeah, no pi for you. And it just makes it a little bit easier. So essentially, we can just generate prolog, which is essentially format, elif64 section, and so on and so forth. And then when I define a function, we can automatically make that function public, right? So that's totally fine. I'm actually curious, right? Because maybe I'm gonna have like a threaded compiler or not like a single path compiler, right? So as I encounter a function, what I can do, I can instantly just generate these two things, public main and main. And then as I encounter extern put char, I just generate this kind of thing. Right. And as far as I know, B was syntactically designed to be a single pass compiler, right? So you just like like parse it once, and as you parse, you generate the code and you have like a final program here. And I think it should be kind of doable. Right. And here's the question. So because of that, can I put extern put char like literally in here? Will it still work? It will. So I can just like go through statements and just like generate some code. So speaking of auto is rather interesting. Where are we going to be allocating all of that stuff? We can literally put them on the stack for now. Yeah, so for all of these things, we can just put them on the stack. And every time you know, do this kind of thing, like you assign something, we're going to write into the memory. And then here, I'm not really sure how we're going to be executing, you know, expressions in here like that, because we need to have intermediate values. So maybe we're going to have a bunch of registers for intermediate values here as well. So for intermediate values, for example, there is a bunch of registers that are like not, how is they called, not clobbered or something, right? So that never change between the calls, and I think they start from like R10, R12, or 11, and so on and so forth. We can just use them sort of as a stack, as a small stack, on which we can, well, I mean, we can just like use memory directly. We don't have to generate optimal code right away, right? So that's kind of important. It's kind of important. You don't have to do that. Anyway, so that's basically the plan. Hopefully it will work out. So let me take a look at the subs. Thank you so much, Howard Rourke 11. Thank you so much for the message. It's sorting a pogging. Can't stop pogging. Pogging. So .i files are used something for C, I believe. I think when we were working with D, when I was hacking dcompiler to make it support .h files, from dcompiler I remember that .i files refer to preprocessed files. They are preprocessed C files without any preprocessing directives or anything. So it's like a final translation unit, right, that you just need to put into the compiler. So if I remember correctly. But I could be wrong. Anyways, b.rs. So I want to kind of have this thing, these sort of enumerations. I wonder if I can take this enumeration and literally port it to Rust. Is that even possible, chat? Chat, is that real? Let's actually see. Rust C enum. Okay, so I suppose I can probably... So this should just work. Enum can also be used as C-like enums. All right. C wrapper. I remember that C wrapper on enum kind of actually made it work. You have, yeah, so there's a wrapper, yeah, wrapper C. I want to see some examples with the wrapper C. So, okay, so this is wrapper U8, but this is not what I want, honestly. Okay, this one is kind of annoying, right? So, and STB Selector uses this as a way to just define constants, right? So because it doesn't even have a type. So Clex ID. Where is the Clex ID? Am I even looking Clex ID? Where is it? Where? Yeah, look at that. It doesn't even define enumeration type. It's just like a bunch of constants. And maybe this is how we should use it, right? So maybe that's how we should use it, but I don't freaking know. Is that a good idea? Ooh. We can actually call this enumeration as Clex. So then later we can refer to these things without this prefix. So it kind of implicitly creates that prefix for us. Something like this, and this is a first unused character. And it's not going to work, by the way, because Rust is extremely authoritarian, so you have to, I think, capitalize them. Shrek? Wait, is there a Shrek? I suppose it's a shift right equal. Right, so shift right equal. Holy shit, this is a Shrek operator. This is not a monad bind. Haskell devs. Fuck you, Haskell dev. This is not a monad bind. This is a shift right equal. Shrek operator. You have no right to call this monad. This is a fucking Shrek operator. Holy shit, a revolutionary discovery has been just made. You don't realize the implication of this discovery. This is a Shrek operator. Holy shit. Okay. Shift right. It's a shift right equal, yeah. It's a Shrek. Anyways. Anyways. Okay, so let's actually try to rebuild the entirety of the... And it compiles, look at that. Ha! So I probably also have to do something like this. Alright. So this is a Klex ID, so that means I can do stbc Alexa Klex ID. So that means it's going to work. But it didn't. I wonder why. I wonder. Expected I64 but found Klex. So I suppose we have to use a wrapper in there. We have to use a wrapper. So if we're comparing it with the token, it has to be schlong. So let's give it a schlong. Wrapper schlong. Okay. Man, so many fucking warnings, like... valid wrappers are Rust default C. Okay, well, I mean, we can put C in here, apparently. Okay, parse error. So, expected I64, but... do you fucking really expect me, motherfucker, to just do some shit as I64? Or... what if I say that this thing is actually Klex? So this token, this is Klex. Is that a good idea? Nah, not sure. Like, I don't want to actually, you know, deal with the sizes and stuff like that. So let's actually say as I64. And for this one, this is a, you know, stbc Lexa Klex int lit as I64. And is it going to... yeah, so it seems to be working. We might as well do something like that. So many goddamn fucking warnings. Why is it possible to... multiple variants are never constructed? How can you not... so it's not about that code, right? So how can it make Rust compiler treat all of that stuff as... like, shut up about unused, I know about unused, right? So how can I make Rust compiler treat it as a library? Because listen, if I'm using third-party library, I'm obviously not using 100% of the third-party library, but the Rust compiler doesn't complain about that, right? So that means, like it knows. How can I tell it? By marking it as pub. Okay, so when you make it public, it actually shuts up about that. All right. So, finally, by the way, okay, so it complains, look, everything that is public, yeah, for enumeration, yeah, you don't have to do that. Like, if it's enumeration, you don't have to do that. You need to make the mod public. Ah, okay. Let's make all of that shit public. Alright, so it complains... okay, so we have unused stuff in here. So that's fine. And what else in here? So there's a little bit more unused. And, okay, so unused here, it's fine. So, see void, that's a lot of things. Like, I'm not sure why. Yeah, and it's just like, doesn't matter. Like, I made this public, I can't make this variants public. Oh, you have to do through cargo. Damn, this language sucks. Holy shit. Anyway, so, and it's just like, it's not gonna shut up about these things being unused, right? It's not gonna shut up about that. Do I understand correctly? Like, it's just, it's not gonna shut up about that. Fuck. Oh, it complains that it's not capitalized. Ah, I see. I thought it's like unused. I didn't even read what the fuck it's yapping about. Because who fucking cares what it's yapping about? Oh my god, this is so stupid. Fuck you. Can I not capitalize that? like, is there something, is there some, like, allow no capital? Yeah. Fuck you. So can I just say something like allow non-common case? Yeah, shut up. Unsafe, call unsafe function is unsafe and require unsafe block. Call to unsafe function is unsafe and requires unsafe block. Bro. Are you... The fact that this function is already unsafe not enough for you? Are you fucking deranged? Rust devs are literally deranged. There is a good reason for it, but it's funny in this context. Will be fixed in 2025 edition. Is it going to be fixed? Okay, maybe we should try a different edition. So, by the way, like, I mean, I think one single unsafe should be enough. Like, fuck you, I'm not gonna be given another unsafe in here. Right, so... not additional unsafe blocks or anything for you. That is more than enough, for sure. That is more than enough. And okay, so for more information, unsafe op in... Ooh, holy shit, wait a freaking second. Lint now warns by default the unsafe... It's not even a mistake, they literally want you to do that. This change is intended to help protect against accidental use of unsafe operation in an unsafe... That's the whole fucking point of an unsafe function! The unsafe function keyword was performing two roles. One was declare that calling the function requires unsafe and that the caller is responsible for upholding additional safety requirements. The other role was to allow the use of unsafe operation. Why do you separate those things? The second role was determined to be too risky without explicit. Holy fucking shit, this is insanity. This language is like insane. Too risky. Did you, like, what is it based on even? How do you measure the risk level? Is there, do you do some research or something? It's just like, it's, or all of that is just vibes. So you're using these like serious words, right? So too risky, like based on what? Right, so where is the research? Where's the numbers? Where's like what? Like how do you determine that? Where is all of that? It's just like pulled out of your ass. Anyways, whatever. So I wonder if we can just try to use... The only reason, by the way, we changed the edition is because we needed the C literals, right? So C literals. So if I try to do something like this... Oh, okay. We can just use 2025, so that's fine, guys. That's fine. Right, so we don't have to use that weird 2020. Honestly, that's too fucking much. Like, that's too much. What if I remove this stuff now? So cool to unsafe. Well, I mean, yeah, so this has to be unsafe. I think this is where I wanted to remove that. All right, so, and here I can do something like that. Ooh, I can remove all of that extra unsafe shit. Holy fuck. That's so cool. Like, 2024 is a little bit too much. I hope they're gonna reconsider that. Is 2024 already stable and established? Is it already stable? This, like, honestly, this is insanity in my opinion. This is just like straight up insanity. Okay, so I can now remove all of that stuff. It's stable. Fuck. Rust is fucked. I'm telling you, Rust is fucked. But anyway, we're just having fun in here. Rust developers don't want you to have fun. They don't want you to have fun. So basically, you may have unsafe function that doesn't actually do anything memory unsafe, but violates some other invariants of your type, doesn't maintain the heap properly and stuff like that. In that case, you may want to be able to dereference row pointers, etc. in that function. So they want to use the word unsafe beyond memory unsafety. So it's kind of, honestly, it feels like that means the word is already outside of its scope. Like, why do you put unsafety beyond memory safety? I thought it was about memory safety specifically. It's kind of weird. To be fair, you're right. Borrow checker already went beyond just memory unsafety when it started to worry about race conditions, right? So just the race conditions kind of beyond memory safety already. So it's kind of honestly fuzzy. It's a little bit fuzzy. I thought it's purely about memory safety, but now we go beyond memory safety. And it's just like, it's very authoritarian and restrictive in some sense. Just like, I don't quite understand. What's the point of that? Anyway, whatever. So 2021 seems fine to me. So I suppose, okay, we need to add a new rule. We need to add a new rule in here. So, okay, this one is optional. Maybe I'm going to remove that. Edition 2021. On the edition 2021. Got him! What you gonna do now? Are you gonna break backward incompatibility? No, you're not gonna do that. There we go. That's the rules of Rust 2021. Anyways. Yeah. Let's fucking go, meine Freunde, fucking go, meine Freunde. So that's pretty woogers. So, we are lexing this whole Scheiße. That's what we're doing, lexing the whole Scheiße. And I suppose the first thing we can do, we can just generate that, prologue, as already said. So I'm gonna go into the test asm. And the entirety of the prologue is basically this, right? So maybe we can even do something like that. So print f, and I'm going to be actually printing all of that to the standard output, right? So because it's going to make it easier, like, manage. So let's put it like that. And it's going to be something like print f. So, and then in here, this is going to be something like that. So this is C, and that's it. So we also have to escape this entire thing, obviously. We're just escaping things. Now, let's actually comment it out, and I'm going to simply compile this entire thing. So it complains about something. Predefined previous redeclaration. What are you talking about? What? C macro. Is that because I don't get it? Wait a minute for me. Is defined in multiple places. What? I think I remember somebody in the chat in a previous Crust stream warned me about that this is going to be, if you have several printfs in a row, this is going to cause problems. This is easy to fix, right? So you just add additional scope in here. It's not a problem. So, so yeah. So because it literally copy pastes the tokens into, not really tokens, but I mean token tree, right? So because it's kind of interesting, Rust macros don't operate on tokens, they operate on token trees. And token trees is literally, it's a token tree, right? So because you can have groups like, you know, curly braces and brackets and stuff like that. So you have literally a tree of tokens that are grouped by the braces, right? And this is needed so you have a sequence of tokens that guarantee to have balanced brackets. So to have this guarantee of the balanced brackets, they don't work on sequence of tokens, they work on token trees, TTs. Right, so we already talked about TT munchers. Oh. Anyways, so yeah, let's actually try to run B, and there we go, it generated. Look at that. It generated a scheiße. Thank you so much, stupid engineer, for which primary the message. Good evening, Mr. Azuz in sodium paper. Hello. Good evening. Good evening. All right, so now we should start working towards different things. So I suppose what we gotta do, we have to parse specifically a function, right? So we're expecting a certain function in here. I think we need to have a helper that lets us do certain things. For example, I want to say that I expect, you know, Klex ID, right? So expect Klex ID. First, I sort of like fetch the token, and then I want to say something like expect token, expect Klex, right? So because this entire thing is called Klex, so let's keep calling it Klex. So here I provide the lexer. Maybe I can provide the lexer just by a constant pointer, and I want to provide just the thing that I expect in here, and it should return me whether true or false, right? So, and if it's false, I want to be able to say, okay, return 1, and this thing, by the way, should actually print the diagnostics for me. So unfortunately, it's kind of difficult to do things like that in Rust. It is not going to work. We get so many subs all of a sudden. Thank you so much, Joe Quinn. Thank you so much for your with the message. Hello, what are you doing today? We are writing a compiler from B programming language, right, to assembly, and we're writing it in Crust, which is a special dialect of Rust, which embraces all of the unsafe features of Rust. So here are 4 official rules of Crust. I'm gonna publish them as I establish them, but first of all, every function is unsafe. Use pointers instead of references, no std, only libc, and specifically Rust edition 2021, no 2024, right? So 2021. These are 4 rules of Crust. So we're programming in Crust, and we're implementing a B compiler in Crust, sort of as a recreational programming exercise, right? So just to have a little bit of a fun. Crust manifesto, yeah. It's a Crust manifesto. Right, simple rules, and it's actually a pretty fun language. Okay, so I can't really do this kind of thing because, okay, well, at least I can just put them on a same, what is it called, on the same line, So we need to do expect Klex. So it's going to be a function that specifically returns a boolean, but it also accepts the lexer. So what I'm thinking is that, do I want to make the name of this thing a little bit shorter? I'm actually not sure. But anyway, so this has to be a pointer. I'm doing something weird. So this is just L, like this. So expect Klex. And we also expect Klex like this. Yeah, let's actually say it's a Klex. I'm going to be copying it in here. Return false. I mean, I can just do false. So, and in lexer, so we have to dereference this entire thing, obviously. So we take the token and we check if it's equal or not, right? So if it's not equal to Klex, and by the way, I confused the order of the variables and the types yet again, because I have to actually switch between the languages, right? So between C and Rust, and it's kind of confusing to me. Right, so what we're doing here, we have to do an error, right? So we have to report an error. So actually do report to std error, like so. I'm gonna say error, like expected one thing but got another thing. So, and in here it's just L token and expected actually collects as I64, maybe as I32. Well, I mean 64. Both of them are LD actually if they're 64. Right, if we're talking about 64, both of them are LD. And since I'm converting it anyway, I might as well just expect I64 so I don't have to do this kind of thing. Right, just convert it as you call this function. Right, and in here we're just returning officially true, but here if everything, I mean false. But here if everything's fine, we just return true. So it would be kind of cool to have a proper like report location as well. Report location. So that's the things we want to have in here. That's the things we want to have in here. So we expect ID specifically. We expect ID specifically, and now yeah, we should take that ID and generate public out of that. So how we're going to be doing all of that? So yeah, I'm going to take L and I'm going to take a string. So I'm going to do printf C like so. So it's going to be public as new line. And that should be enough, I think. So if I try to now run the whole thing, so yeah, so this has to be as I64. So that's what we expect in here. So dereference the row pointer, yeah, it has to be unsafe. I'm totally fine with that. And now let's just try to run B. And as you can see, it did public main. Right. It already starts to generate things and stuff like that. But on top of that, it also have to generate the label. Right. So let's actually make it generate label. Look at that. So it generated the prologue and then it encountered the function, it generated main. So if we change this thing to something like foo, right, it now is going to do foo. Right. So, but in our case, the entry point is this entire stuff. So after we encountered the function definition and stuff like that, we don't really, we're not going to support any parameters of the functions yet. We don't support any parameters of the function. Because of that, let's say that we explicitly expect, you know, open parent and then close parent. But I mean, before we can actually check what we expect, we have to fetch and then check that this is what we expect it is. Right. So let's actually try to do something like this, right? To like make it error and just see what's going to happen. Right. Expecting 91, but got 40. So now if I replace it with that, it changed the number. And now if I try to do something like that, it actually went okay. Right. So it, you know, it checked that we received all of these things. It checked that we received all of these things. Honestly, it would be kind of nice to actually combine together expect collects. So let's actually create a different function. I like to actually have this as two separate operations. So yeah, STB is actually kind of useful. STB is kind of useful. So we just like have already pre-made Lexa that we can just use. Right, so we don't have to worry about that. Furthermore, we can even get the locations where exactly it happened. Let's actually do that, right? So I put that into to do, but I think it's worth to actually try to do that. So there was a location, so get location. So here's the function that gets the location. All right, so you have to do a little bit of this stuff in here. So public fn, so this is the link name that we're gonna have in here. Link name like that, and it's going to be get location. So you have to specify Lexa by a constant pointer, by the way, because it's not going to modify it. So this is a constant pointer. Where, god fucking damn it, like why did you squatted such a nice name, Rust? What the fuck is wrong with you? Anyway, so let's put something where. And it's going to be const pointer to cchar, right? And then we need to have a STB location. So that's kind of the thing. So STB location is actually a pretty straightforward thing. Let's put it in here. STB locazione. STB locazione. So, and we can call this function when an error occurs. When an error occurs. So I can just take that, then something like that. And then put cint like this. So, and that means here we just have a mutable pointer to le location. So, and every time an error occurs, what we can do, we can create stb location, right? So we can say lock, it's going to be mutable, obviously. Let's allocate it on the stack and let's make it zeroed. So stbc lexa, like so. So this is the location. Then we must get the location where exactly this shit has happened. So get location L, and then where, as far as I know, the lexa itself stb has, yeah. So basically it has two locations. First character of the token and the last character of the token. We kind of want to have like a first character of the token. So I think I'm starting to get the gist of the lexa and understand how exactly like to use it. And it's actually rather convenient, believe it or not. It's rather convenient. So now I save, yeah, this one has to be lock. All right, I save this entire thing into the location like so, and now I can use this location, believe it or not. Right, so we have this thing, and I'm thinking, can I just use it somehow, like, because I want to have a constant, right? So const file path, which is, can I make it something like that? I have a feeling that I won't be able to make it like that, right? I think it won't allow me to do it, but then it's going to be super easy to do something like this, right? So we have number n of set, right? So this is going to be number n of set like so. So that means here we can do file path as ptr, then location line number, location line offset, and then we do clex, and that's a better error reporting if it works out, obviously. If it works out, I don't know if it's going to work out, but yeah. So report location. So let's see. So it doesn't like, okay. So first of all, this has to be commas, right? All of these things have to be commas. This one is not public enough. That's understandable. Let's make it public. What else do we have in here? Should have been uppercase. Shut the fuck up. Shut the fuck up. Shut up. Fuck you. Okay, so what else do we have in here? So SPTR, like, it's already PTR. We don't have to worry about. This is perfect. Brovskis. That is perfect. Believe it or not. So you can actually do this kind of things, and it's just like a, yeah, because it's a pointer within like a static data section or whatever, so you can actually use it. This is convenient. Holy shit. Okay. So that means I can do file path like this. Damn. Yeah, so it will be kind of nice to have autogen for all of that stuff. But now, look. If I put this kind of thing, it reports you the location. The offset is kind of meh. I agree with that. The offset is kind of meh. And first of all, we have to put this kind of thing. So, but we can do +1 for this specific offset. Look at that. And it gives me, so it expected one thing, but got a completely different thing. So that is very fucking cool. So we can even have locations and stuff. Another thing that we expect in here is probably open curly, right? So that's what we expect. That's what we expect. So it's totally fine. So pointers in compile time evaluation probably are implicitly slices. Maybe that's what they are. Anyways, I want to combine together this operation of getting the token and expecting it. So the most logical thing would be to actually tuck get token behind expect clex, but from my experience, you actually want these two operations to be completely different, right? Especially if you are consuming a variadic amount of things like parameters and stuff like that. Quite often you want to get and only then check, so it has to be kind of separate thing. So yeah. Let's actually maybe do another stuff in here. Get and expect class, right? Sometimes you want to do it as one thing, but sometimes you actually don't, right? So it has to be kind of separate operation. So I'm speaking from my experience in here. So, and this is where we want to combine this entire stuff. So first we're getting this entire thing, we're getting it, and then we pass in expect in here, like so. So it's going to be that, and then just that. Super easy. So, and that should enable us to get rid of some of these things. So get and expect. This get and expect. Get and expect. Get and expect. Look at that. Now it looks much better. So look at this code. This is so fucking cool, right? So it's just like, yep. So we encounter like a, you know, name, then we generate the label and declare it as a public, and then we expect this kind of thing because we don't really parse anything in here. Match operator allowed. I don't understand what you're talking about. Anyways, so let's actually continue. What do we have in here? We have an external put char. I suppose in all of these situations, statements start with class ID. Match or switch cases of, I know that, I don't know what the fuck you're talking about in the context of what I'm doing right now. Okay, so all of the statements are, they seem to be starting with class. So that means it's kind of safe to maybe say that, okay, expect specifically class. Right, so we're expecting class, and then depending on what kind of class we have in here, we can do different things, right? So let me actually see, but to do comparison for the strings, we need strcmp, by the way, right? So man strcmp, so we need this thing. So let's go ahead and actually put this over here. So where's the libc? Here it is. So we have a bunch of wrappers in here. I didn't think I want to have a wrapper. So let's do extern C like that. Fn, obviously unsafe. It returns C int. And this one is S1. Const pointer to C char, like so. Const pointer to C char, like so. And there we go, we have strcmp. And this is Crust. So it looks a little bit C-ish, but this is because it's Crust. So this is what we're going to be doing in here. So we want to do comparison between this string and extern, right? So if we encounter extern, we're going to do one thing. So else. So then we're going to have, where is the main.b? So we can have auto, right? So that's another one. That's another one. And then if it's something else, it is probably a symbol. In that case, it's either an assignment, right? So we'll have to look into the next character in here. It's either an assignment or it's a function call. And they're kind of easy to distinguish, honestly. They're kind of easy to distinguish, I think. Right, so that's basically what we're expecting here. When we start parsing the statements, and this is a statement, at least for now, right? So we're probably statements are not, this is not how you parse the statements in B, but we're implementing right now, as of right now at least, a small subset of B, right? Specifically, whatever gets us this thing compiled, right? Yeah, it's kind of is like zip.php. It's kind of is, but I think not a joke, right? So, right, so the going further, you can actually make it more complex, because this is how you start. You start from very simple things, and then you continue piling things on. So it is kind of similar to CPHP. And it actually kind of shows you that the languages don't matter, right? It's just like, it's all about translating one language to another language. It's all just like, it's trying to, it's going around the circles of the same thing. You know what I'm talking about? Like all of these languages that get translated to other languages, we're kind of like wandering around trying to find this one thing, and we can't really find it. Right. because it's like it's all the same, but at the same time we can't really pinpoint it. Do I make any sense, or am I schizoranting yet again? I feel like I'm schizoranting, but anyways. So I do make sense and also schizoranting. I see. It will be kind of nice. Your point there clicked for me the first time I saw you use FOSM. Yeah. So, and that actually like working with FOSM and with assembly and then writing languages and converting one language to another, like kind of shaped my perception of languages. That's why I don't care about them anymore, because I realize that it's all ephemeral. It's not about them. There's something deeper, right? There's something deeper that all of this craft of languages is hiding. Languages are really fun to make. Yeah, they are kind of fun to make. You know what I want to be able to do? I want to be able to do things like these kind of things. But I feel like this requires std, so it's a const. So what are you talking about? I don't quite get it. So it doesn't have to be like that. It's a S2. Electric Boogaloo. S2. And you want to have C char. Maybe it would be easier for me to just like import everything in here and forget about it. Yeah. So it's a libc. And in here also we have libc. Libc. So function is private. God fucking damn it. All right. So mismatch type. Well, I mean, you don't have to do it like this in here. Mismatch type differ. Really? Oof. This one has to be mutable. I do agree with that actually. Okay. So, and this one has to be mutable, and all of these things have to be mutable. Okay. Even here, mutability kind of haunts me. It still haunts me. Chat, save me, please. Okay, so this one has to be C. This one has to be C, but at the same time, it also has to be as PTR. Maybe we could implement some sort of conversion, but maybe not. I don't freaking know. So, unreachable expression. Ooh. Any code following this. So, you telling me that to do will just work? Oh shit. But it's a core. Why panicking is not working? Huh. That's very interesting actually. Why panicking is not working? Is it because I have my own panicker? Is that what it is? Flag. What flag? What do you mean by flag? I didn't understand. So here is the panicker board thingy. Extern create core. That's an interesting idea actually. Extern create core. So, oof. And the inner doesn't annotate the use import. Doesn't work. Because of panic handler. I don't know. So one of the things we can do, by the way, we can introduce abort. Sorry. Please forgive me. So here is the abort. So what we can do here is something like this. But it also would be nice to maybe print something like this. And if I do line, it's not gonna give me null terminated choice. But we can do something interesting. Okay, so we can do something like extern. Because why not? And this one is going to be auto, and this is going to be rest. And it's more of a like, all of these things are statements, right? So we're parsing the statements specifically. What do you want from me? I know what you want from me. libc, and also let's remove this semicolon. Yeah. So that's enough for me, honestly. That's enough. So we encountered extern, right? So we encountered extern. And if we encounter extern, we need to expect ID, All right, so we specifically expect an ID. Okay, that's understandable. That's understandable. And as we encounter ID, right, so we probably have to print something like C extern S, and that is basically string in here. Look at that. So extern put char. Extern put char. That's pretty cool. And I suppose, at least for extern, right? So because it's a very small subset, we probably want to just go ahead and expect a semicolon. Let's just expect semicolon like this. I'm gonna put it to do support multiple extern declarations. So this is a to do in here. This is a to do in here, and it all seems to be working. It all seems to be working, and I think we're gonna declare this branch finished. This is a finished branch. And if I try to compile this thing, it complains because of the type that we return here. We're supposed to return this kind of thing. So I might as well even do something like that to do program. Right, so we are compiling program, and if we do that, we actually fell through. Yeah, we fell through in here. So that means that what we have to do in here, as we parse, we have to do all of that stuff in a loop. Right, so we probably can do something like this, but I heard like loops are sort of like, I don't freaking know, not really defined behavior or whatnot, right? So the optimizer can optimize it away. So by the way, I haven't neglected these subs. I really apologize for that. So you mod the god, I hope I'm pronouncing that correctly. Thanks so much for the message. Hi, new YouTube site episode, very cool. Thank you to Kamikaze who came up with a sub chat, right? So I didn't do that myself. Right, shout out to Kamikaze, a very cool developer who implemented this entire thing. I contributed a couple of things that I needed for subchat, and I'm really grateful that he actually merged them, even though he didn't like some of them, but I still really appreciate that. So, and as far as I know, he plans to actually make it even cooler, right? So you probably noticed that some of them, like messages, are split into the chunks, and you can move these chunks around, which is not particularly convenient, and also makes the CPU spin up a little bit. So he said that it's going to implement it as a single chunk, right? So you will be able to move that single chunk at some point. So apparently you can actually style things within a single chunk. So that will be actually kind of cool. So yeah, check subchat out. Maybe you can use it for your project, for your videos. I don't know. So it's very cool. Thank you so much, Kamikaze. So Andrea Herman, thank you so much for the Prime with the message. More months to go. More months to go, indeed. So and Joaquin, I don't remember if I acknowledged you with the message. Hello, hello. What are we doing today? We're doing decompile. I think I already acknowledged you. The zero at the end of main is intimidating me. Why it is there? This is because of Rust, and Rust is expression based. So essentially, this function returns integer, and the last expression in in the body is the one that's going to be returned. So it's expression based. So anyways, yeah. So let's actually continue. So we have to do that like in a loop in here, as you can see. We're doing all of that stuff in a loop. Okay, so and we reached statement auto. Right, so that's what happened. We reached statement auto. And this is essentially what we have to do in here. So in this specific case, you know what? I kind of don't want to parse multiple auto things. Yeah. But I mean, maybe it's not a particularly convenient thing to do. So cheating, well, I mean, we're implementing a subset anyway, at least for now, so I don't know, we'll see. So, and then we get the ID, right? And the question is, what the fuck do we do with that ID? So that's the real question here. Implementing A now, yeah, so it's basically A. So, yeah. So we probably have to keep track of the names and their offsets on the stack, right? So essentially we have some sort of a stack in here, and here is RSP, right? So what we want to do, I suppose, we want to just generate, you know, some code that does a subtraction. So let me actually see. I think we can do something like subtract RSP 8, right? So this is the size of the word, right? So, and we're going to be using 64 bits because I'm pretty sure original B was not using 64 bits, but it's all of the variables are words, and a word in x86-64 is 64 bits. So because of that, our variant of B is going to use the size of the word 64 bit. Good thing is that you don't need an offset, only the number of variables, because they're all the same size. Yeah, this is actually kind of cool. This is the cool part of... Damn, that actually makes it generating code for B's easy. And I think Ken Thompson himself actually said that in the document. So... sharing the... Okay, B was designed and implemented by Richie and the author. Damn, I don't remember. I think he said somewhere that it was designed to be easy to actually write a compiler for. I don't remember where he said that, but I'm already a little bit tired, so I'm not gonna do that. Anyway, so yeah, so we're just allocating this kind of thing. This is what we did in here. We allocated the variable. And I think that's basically it. So we just allocated that. We need to save the name of the var and its offset. We also need to keep track of the RBP, I suppose, right? So, and its offset. Okay, so I'm gonna do that. So after that, I'm expecting this thing. Also support multiple auto declarations. Multiple auto declarations. Save the name of the var and its offset. Then we expect that. So that seems all right. Look at that. Fascinating, isn't it? Fascinating. Okay. So now we are actually going in here. So this is where all of that happens. And I suppose, as already said, within any declaration, we kind of expect it to start with ID. So that means if it's neither extern nor auto, it is an ID, right? It is an ID. And we need to kind of save it somewhere, right? So because we have to look ahead, whether it's an assignment or a function call depends on the next token, right? So it's going to be either equals or it is going to be open parent, right? So that's basically what's going on here. So it's either two or that or that. So we have to save this entire thing. So because of that, we need strdupe. So let me see. So strdupe. Let's go to the mode libc. So this is libc. So it's going to be public fn. We are returning mutable cchar. By the way, mutable cchar. It's going to s const cchar like this. So, and what we want to do in here is, well, I mean, I forgot to make it public. I actually didn't. strdupe l string. So this is the ID we're working with, right? So this is our ID. I'm going to keep it like that in here. So after that, I'm saying that I expect the next ID. Actually, not really. I'm not expecting anything per se. I'm expecting something. Because of that, I just have to do get token, right? So I'm just doing get token, and then I need to look at the token and see what's there. Right. So, and we have several situations in here. As already said, it's either equals or it is open parent. So that's the only thing we expect in here. So L token is equals as I64. So in this specific case, it is statement assignment, right? Otherwise, maybe here we can do match, by the way. So this should allow us to do a little bit of a match, I think. But I'm not sure, like how, yeah. Yeah, well, let's not do that right now. I'm gonna do it a little bit later. So L token equal to open parent, like so, as I64, and this one is fun call. This is a fun call, function call. And in here, this is probably where we want to report an error, right? This is where we want to report an error. Interestingly, we need to repeat the codes for diagnostic that we already have. So let me do statement report unexpected token. So in here, this is the code that we'll have to repeat quite a lot, actually. Quite a lot. What we're building today, we're building a B compiler, right? So this is the language that is predecessor to C, right? And we're implementing it in Crust, which is an unsafe version of Rust. So that's what we're doing today. And we're almost there, right? So, I mean, we're hacking a lot of things, but that's normal. That's totally normal in here. I'm also a little bit tired, and I'm actually approaching 3 hours. Right, so what I'm thinking is that maybe I'm gonna finish already tomorrow and maybe even in an offline session. Right, so because already like hacking the code for almost 3 hours. And almost there, actually, almost there. So I just need a little bit of a sleep, right? I don't want to push myself because every time I push myself, it doesn't really work out. Right, by YouTube, fuck you. Yeah. So maybe I could do another online session, but I feel like another online session is gonna be too much because there's not that much left in here, right? So I don't think I have enough content for another online session. So I better actually just finish it offline, right? So, and put it as a, footnote and stuff like that. But you get the gist of what I'm trying to achieve in here, right? So as you can see, if you just extrapolate of what I'm doing in here, you can quite easily achieve compilation of this thing down to x86-64 assembly and get some sort of a subset of B compiler that you can then continue improving and maybe eventually implement the entirety of this thing, right? So I'm gonna finish this example offline, right? Obviously I'm gonna record myself, right? And then we'll see, right? So whether it's worth continuing this series or not. But what I can tell you is that draw the rest of the wall, exactly, draw the rest of the wall. But what I can tell you is that Crust is actually quite capable for what we're doing here, right? So far, we didn't experience that much friction. And by the way, so far, we haven't encountered a signal seg fault, did we? So there was 3 hours. Does anybody remember a single seg fault so far? Like we put unsafe literally everywhere. We were not putting like references or anything, but it's just like there was not a single seg fault. It's not safe, actually. It's not safe, right? But I mean, okay, so I'm memeing a lot, but I just want to, make a disclaimer that information security is not a joke. I honestly wouldn't write in Crust some sort of like a critical backend that is facing into right, so I wouldn't try to do that. But for things that are local, that are compilers, I think it's kind of fun thing to explore, right? So, but I would not write a server in this kind of thing. I would rather prefer a safe Rust. Though, having said that, Nginx, the most used web server on the internet, is written in C. So it's not impossible to write a safe C, it's just like it's a little bit harder, right? So Qmail is also a thing that is heavily used and it's also written in C. I don't know.
CVE search and well, yes, there is a lot of CVEs in Nginx. I know that. So, but at the same time, everybody's using it. Right. So, anyways, okay. So that's it for today. That was a fun session, but it's not over yet. It's not over till it's over, right? So I'm gonna finish it, right? Watch the rest of it on YouTube. So it's gonna be super fun. Yeah, and I see you all next time. I love you all. Mwah. All right, this is the next day, so I decided to do an online session instead because I overslept, so I couldn't finish the offline one on time, so I decided why not go ahead and just stream it. So Sandy, thank you so much for the sub, thank you. Right, so let's actually see where we stopped. Right, so if I try to compile this entire thing, it doesn't even compile. Damn, Brovsky. So what do we have in here? Oh yeah, so I'm supposed to actually take this thing by a reference. Like, I don't even know what this code does anymore, right? So I literally wrote it yesterday. So it took me one day to completely forget what this code does, but I think, yeah, so essentially we are parsing statements in a loop. Right, so, and we're looking at what the statement starts with, and if it's extern, that means it's an external symbol, we generate external symbol. If it's auto, that means it's a local variable, automatically allocated and deallocated on the stack. If it is just an ID, we assume that it is either assignment or a function call, neither of which, by the way, are statements. Right before the stream, I actually properly read the spec of B. Neither of these things are actually statements, they're expressions, and they're specifically R-value expressions, and just a standalone R-value expressions could be actually statements, which means they are statements. So it's kind of difficult, right? So they're expressions, but they also could be statements and stuff like that, almost like in C. I think it is the case in C as well. But anyway, in any case, we are trying to make it work on that, like a small hello world-ish example, so we are allowed to hard code things. Okay, so let me actually make this entire thing compilable and just see what's going on in here. So unreachable statement, that's very interesting. Why are you telling me that this is an unreachable statement? Ah, this is because it's a 2.9. Right, and in here it is unreachable because all of these things are aborts. Okay, so this is very interesting. So that actually makes sense. So I suppose we don't have to do this stuff in here. So that is true that it is unreachable. So, and in here is another one that is unreachable. It's a 2.1.1, which is also unreachable. Okay, that's pretty cool. Look at that. So the Rust compiler is still being useful, even though we turned it into Crust. That's pretty cool. So yeah, so control flow analysis still exists and it's still pretty useful. Okay, and honestly, Rust is so noisy with warnings that makes me almost always ignore them. So if you're being too noisy with warnings, you kind of defeat the whole purpose of warnings, aren't you? Right, because you just like encourage people to simply ignore what the fuck you're saying. You fucking yapping too much. If you're yapping too much, nobody's gonna take you seriously, right? It's just like, it's just yapping again. Nobody gives a fuck, right? So you're literally destroying the notion of a warning by itself. And maybe that's why people, like a lot of like very experienced developers, don't like warnings at all, and they rather prefer errors instead. So alternative in Zig, well, it's not only Zig thing, right? So a lot of other modern languages also trying to just make everything an error, right? So because if it's not an error, like why even bother reporting that, right? You're just like wasting the developer's time. So anyway, so now let me try to run the compiler. Right, so, and we allocated a couple of variables, and now we're looking at the statement assignment. So this is where we have to do this kind of thing. But to be able to assign anything for a statement, we need to know where the variable is located that we just allocated in here, right? So I suppose one of the things we have to do, we have to store the offsets of the variables somehow. So, and essentially, by the way, if I take a look at the output in terms of assembly, RSP is constantly moving around, right? It's constantly moving around, and by itself, it is not a very reliable position from
like from which we calculate the position of the variables, right? So usually for that we're using RBP, and one of the things probably we have to do when we're compiling a function. So here we are in fact compiling a function, don't we? So because here we expect the name of the function, then we just make this function public, and so on and so forth. So somewhere here, what we have to do, we have to probably do the usual prologue of a function call, or not really function call, but the function body, where is we just save RBP, right? So because RBP is currently something, right? So which is inherited from the previous scope, right? So let's actually save that, and then we have to, I suppose, basically move the current RSP into RBP, right? So the current stack pointer is the current sort of base in here. So if we take a look at the memory a little bit, so here's what we have in here. The stack is located somewhere here. So let's actually put something like that. This is RSP, and we also make it RBP. So then when we allocate something on the stack, RSP is actually becomes here, but RBP is not moving, and relative to RBP, we're going to compute the positions of all of these local variables in here. So that's basically how I plan to approach that. So this is the stuff, and I also probably have to put a new line in here. So if I try to maybe recompile the entire thing and maybe run this entire stuff, so that seems to be working. Probably it would be a good idea to maybe indent everything that is inside of the function body, so we can actually sort of see where the function is located, so to speak. Right, so there you go. So here is the main, so section, executable, and this is the usual prologue of a function. We do external char, we allocate a bunch of variables in here. But as we allocate the variables, I think we need to save their offsets relative to RBP somewhere. Right, we need to save this offsets. So it means we need some sort of a table in here. Right, so let's maybe create some sort of a structure, which is going to be like autovar. This is the autovar, and it's going to have the name, right? So it's going to be mutable char, maybe not even immutable, could be just a constant one. Since we're programming in Crust, all of the strings are basically C strings, right? C strings. And we probably want to have some sort of offset, right? So this is going to be usize, but we also have to store this entire stuff somewhere. We don't really have hash tables, do we? We could have hash table, by the way. Who said we can't use stbds? Right? So basically, we can do that. So it's a header on the library, so we can try to use this entire thing. That would be kind of interesting. Wait a second. So, well, at the same time, we can just use linear arrays, right? We could use linear arrays, but using stbds sounds like an interesting idea because I don't think it's that difficult, honestly. How can you use stbds if it's mainly macros? We can implement macros. We can actually do that. Let's give it a try. I'm actually rather curious. So this is going to be something like this, and let's do wget, and it's not that many macros anyway, right? So for example, hm get I, right? So this is one of the function that we need in here. hm get I. Okay, so it points to macro stbds hm get I, and inside of this thing, it's this macro. So it's not even doing that many things. So first of all, it's trying to get a key wrapper. We can take a look at what that is. Okay, so this is a C++ version, and this is the C version. So yeah, so it's actually wrapper. So here it is. So it's an actual C function. We can redirect to an actual C function in here to get a key, right? And then stb address of, so here is an address of, I suppose, of the, oh, it's literally, yeah, it's literally just a pointer, just a pointer to this entire thing. And also stbds. Okay, so we can just like implement all this as a macro in Rust. I'm pretty sure we could. So let's go ahead and try to do that. I wonder how. We need to set up some sort of like a test environment for all of that stuff. So let me copy paste this thing. So stb, stbds, and this is stbds implementation, stbds.h. stbds, yeah, it is in fact stbds implementation. Let's grab the object file and let's just compile this specific object file. It does in fact compile. Right, so also link all of that stuff in here. Right, so let's rebuild this entire thing. Right, doesn't compile, something is wrong in here because it's not a cchar. Well, I do have cchar, don't I? Yeah, I keep forgetting that this has to be a comma, actually. I keep forgetting about that. Okay, so everything's fine. Let me see. So here is stb lexa. Let's introduce pub mod stbds, right? So this is stbds, and we're already starting to have like 2 stb libraries in here, and somebody suggested to maybe have like a bigger module stb. We could do that at some point, like maybe not right now though. All right, so how am I going to do all of that stuff? So if you're using stbds, you are supposed to create a structure with 2 fields, key and value. That's what you're supposed to do. Let me find some examples in here. So there was hash maps. Yeah, so this is the structure that you must create, right? So it has to be key and it has to be value. And as far as I know, key can also be char star. By the way, immutable, but maybe it doesn't matter because we're going to control that anyway. So let's actually call this something like key, and this is going to be the value. So this is what we're going to try to store in the hash table, right? So, and your hash table is going to be something like, so vars, just a pointer, mutable pointer to auto var. This is what, how it's going to work. All right, so maybe we're going to put that in here. So stbds, let's try to implement put, right, which puts a particular entry into the hash table. So somewhere put. So this is the macro. It's kind of interesting that it strips the prefixes. So it's kind of a similar mechanism of stripping prefixes like a knob, but it's stripping prefixes always by default, and you consciously tell it not to strip. This is actually might be better. I don't know why I didn't do it like that. I should have done it like that. I mean, Sean is obviously way more experienced developer than I am, so yeah. So that's understandable. I'm just a stupid dummy developer. Okay, so where is this macro? Now we need to actually write a macro, like basically port this macro to Rust somehow. Yeah, exactly. No, please don't nuke my house. I fell into the same trap, apparently. I fell into the same trap. So macro rules. So, and in here, by the way, do we even have to make it? Yeah, we do have to make it, right? But by the nature of how all of that works, we do in fact have to do it like that. Okay, so this is going to be put, and in here we're going to have a bunch of other things. So I need some examples, macro rules. So this one is going to be essentially T, K, and V, right? So that's basically what we expect in here, and then you put this fat arrow. Right, so this is the fat arrow, and this is what you have to put in the body of this entire macro. Okay, and this is actually a single expression, as you can see, right? So it's a single expression, but Sean is using comma operator to sort of achieve sequential execution. So this is how it works. This is the sequential execution. Actually, this belongs to this specific function call, so it has to be like this. Okay, this is a huge single function call, right? This is a huge single function call, and by the way, we can actually rewrite it something like this with semicolons and stuff like that. So the only reason why Sean actually wrote it like that is because he wanted to act like a single expression, but in Rust everything is expression, so you don't really have to do it this way. Right, so we can just like write it normally. Who said we can't do that? We can just write it normally. And in fact here maybe I can even replace this kind of stuff with just like T. There you go. So this is what we got in here. So here we also take size of this entire thing. So T is supposed to be basically pointer to the hash table, right? So it's basically a pointer to the hash table. Right, so, and we are passing it to this magical function. So it's a wrapper. And the reason why it is a wrapper, I don't quite remember why it is a wrapper, honestly. I think this is because in C++ it's literally a template, but in C it's a direct call to a function, right? So because of that, they just basically called it a wrapper. So I think we can be directly calling to the C function, right? So we can essentially just remove that thing in here and just find this thing. So where is this function? And this is basically the function that we're calling to. So, and essentially, let's just, you know, declare this function so we can use it inside of this macro. Right, so it's going to be extern C as usual. So this is the one. We'll probably also have to do core FFI stuff. So let me do something like that. Honestly, I'm kind of tired of like including different types in here. So I might as well just like include everything. So fuck that. Right, so this is going to be fn, it's obviously going to be public, and it's going to return mutable C void, right, that's what it is. So here we are accepting the hash table itself is just a C void, right, so this is how you do generics in C. Right, this is utterly cursed, yeah, because we're actually using a C library from Rust, and that specific C library is actually utterly a hack. Right, it's the most hackish library like in C. So yeah, but I think like doing this kind of stuff is kind of insightful, right? I think it is extremely insightful into how low level works, right? So I do not recommend writing like mission critical applications this way, but as a way of like, you know, as entertainment, like as a recreational programming, I think it's kind of fun to do it this way, right? So just like explore, like, can you use stbds single header library from Rust? Let's fucking find out, right? Why not? It sounds fun, honestly, to me. It sounds fun. So this is going to be C void. So this is size of the key. So use size, and this is some sort of a mod. Right, I don't really know what the fuck is that, but apparently it is like they passed just 0 in here, so it doesn't really matter. So this is cint. I think it was cint, yeah, it was cint. Okay, so this is the function that we got in here, and in fact we can maybe do a little bit of a like a link situation in here, link name. Right, so that's the name we're gonna be working with in here, and I can just nuke this specific prefix, so I don't have to work with it anymore. So when I'm calling this function, so what I want to do in here is just like put key. So I pass this thing in here. Now I need to dereference this pointer so I can get the size of the internal type. So, and as far as I know, Rust in fact does have size of, but I'm not sure if it's going to work that easily. So is it going to just like infer the type? I think it should be able to just infer the type. Yeah. Oof. So how do you do size of a value rather than a type? Do you guys know? So let's find out. Well, Rust up doc. It's like what's up doc, but Rust up doc. Ahaha. Size of val. Okay, so thank you so much. Size of val. Let's see. Intrinsic, by the way. So that means I can just like use it. All right, and it's also part of the const. Fuck. What if it's size of val? Size of val. Is there any other size of raw? Why is it const though? Because I don't really have const. Turn size of a pointed to a value. Well, I mean, if it's mutable, it probably can decay to const, right? So maybe that's fine. Size of val, right? So size of val. And what's funny is that since it returns you the size of the pointed at, right? So since it returns you the size of the pointed at file of val, we don't really have to dereference it anymore. So this one fucking nightly. So that's kind of bad, honestly. That's kind of bad. STD though, but maybe there is... This is so freaking bad, but I mean, so it's also part of the memory, so this is... oh. But it's It's a reference. It's kind of funny, size of val, but accepts a reference. Size of val row, and so this one accepts, and it's nightly. Is there something like type of? Does anybody know? Type of. When are they gonna finish this language at least to some usable state? It's insanity, honestly. Right. So okay. So I'm gonna try to do this kind of thing. So size of val row, and I'm gonna just do useScore mem. Oh boy, Jesus fucking Christ. So, and because since it accepts the pointer, we don't have to dereference this entire thing because it's already a pointer. We don't have to worry about that. So stb address of, what the fuck is address of? If I remember correctly, it's just a more cross-compiler pointer. Yeah, I do remember that. So it essentially allows you to take a pointer of R value, which is not something that you can easily do. Right, in C. So they use a little bit of a trick of like compound literals and stuff like that. But I think in Rust we can easily do that. So essentially in here I can take a K and I can take a reference to this entire thing as a mutable. Right, I'm not sure how good of an idea that is, but anyway. So, and here we also need to take a size of the key. Alright, so this is going to be mem size of value row, but I mean it doesn't really have to be so it's just a key that we're passing in there, just a key that we're passing in there. I'm actually thinking I think this has to be a generic. Honestly, I feel like this has to be a generic to work properly, but it is not going to work that easily, right? So because, yeah, apparently it's very difficult to use it in Rust like that. Huh. Okay, so unless we have these functions, right? Unless we have these functions, it's literally impossible. But yeah, so let me, I feel like I'm gonna waste a lot of time on this thing. I really feel like I'm gonna waste a lot of time, so I don't really want to go that route. I really don't want to go that route. Yeah, fuck that. We're not gonna go that route because I already feel I'm gonna waste a lot of time figuring out how to use size of value and size and like whether there is an analog in non-nightly. Fuck that. I can smell a huge rabbit hole from the mile. We're not gonna go that route. Okay, so we tried it. It's not gonna work out. Fuck all of that. Okay, so because I don't really want to waste in time on this kind of shit. Okay, so what we're gonna be doing, we're gonna be using like a dynamic array. Right, so just linear search and stuff like that. Okay, so where's the auto var? This one is gonna be name and this one is gonna be offset. Okay, and so where is dynamic array? We don't really have a dynamic array in here, but we do have a dynamic array in the Crust repo, right? So by the way, I actually uploaded the example that we did in Crust to GitHub, and there is a dynamic array example in there, right? If anyone is interested. So let me go to the description in here, right? So something like that, and let me now try this kind of stuff. So instead of this kind of pointer, we're gonna have an array. So this is Crust, main rs, and I think the module was ds, right? So data structures. Let me copy paste the data structures in here. So this is expect clicks. I'm just like looking for the place where to place all of that. So this is the dynamic array implementation that we're gonna use in here. All right, so here is the vars, vars, not vars. Okay, ds array like this, and this is going to be the zeroed. So this is the zeroed one. So by default, it doesn't contain anything. All right, let's try to compile this entire thing. Okay, that seems to be fine. So this one is unused. So name is never read. I mean, nobody gives a shit. This one is never read. Let me make this thing public so it doesn't complain about this stuff. Okay, so this is never used. This is also never used. Okay, that's pretty cool. Now, as we encounter, and this is very important, as we encounter new auto variables, we need to push them into this dynamic array. So let's go ahead and do that. So here is the variable. So yeah, we got an ID, right? And we expect a certain ID in here. Where did we do str_dupe? Did we not str_dupe the... so here, this is where we did str_dupe. So what I'm thinking is that now we need to take the name and also str_dupe that name in here so we can use it. We also need to keep track of the global offset, right? So vars offset, and this is going to be usize, and originally it is 0, right? Originally it is 0. Now, as I encounter the new thing, so this is going to be the name, then I take the vars offset and I add the size of the variable, which is 8. So this magical value we probably want to factor it out into some sort of constant or something like that. And this is the current vars offset, and this is what we want to push into vars. Right, so ds array push. Right, so we're accepting this thing mutable in here, and then this is the auto var. And as far as I know, this is just the name. I can just use it directly. And offset is the vars offset, like this, and there we go. We pushed that thing into this dynamic array. So this is basically the to-do that I just implemented, right? So just do that. Okay, do we need to do anything else in here? Do we need to do anything else in here? I actually don't think so, so that should be enough. And as we go into this assignment, one of the things we can do, by the way, we can iterate through all of the variables that we detected and print their names and their offsets, so we know that we actually detected them. So this is I, then vars count. So this is what we're doing here. So this is vars items add I. We've got this thing in here, we're going to dereference it. Then we take in the name, and I suppose we can just like print f in here. So this is going to be simply the name, and then this is going to be the offset. So this is a new line. So this has to be a macro. And then in here, we just take and use the offset like this, right, before we go into the abort. Okay, so let's try to rebuild this entire thing and go through the compilation errors. Autovar is not, so it doesn't like something about the vars, is because the vars not mutable. Didn't make it mutable, so it is mutable now. What else do you want from me? So autovar mismatched type, that is a little bit bizarre. So array push accepts the item. So expected mutable but found auto. This is... What the fuck are you talking about, Brovsky? You should not... This is probably because I accidentally forgot to remove the pointer in here. It should not be a pointer. Now it compiles. Okay, if I try to run this entire thing, this is basically the variables that we got. Right, we got only variables A with offset 8 within the stack and a variable B with offset 16. And if we take a look at the source code of this entire thing, that is true. We have A and B, and we actually detected their offsets. Okay, so now if we need to access the variable, we know where exactly on the stack it is located. Make sense? I think it makes sense. So that's pretty cool. That was actually kind of important. To be fair, this is not enough. We also need to maybe report variable declaration. Yeah, var declaration duplicates. So essentially right now we can actually declare A twice. So, and it will Yeah, as you can see, it's just like allocated another variable in here, and with this offset, and it just subtracted the stack one more time. So we can try to spend some time doing this kind of declaration. I don't know, is it even worth it? But we can try to do that. So maybe we can. We need to have some sort of a function that finds, finds a value within an array. We don't have slices, by the way. Chat. Did you know that we don't have slices? Because we don't use references, and slices are defined through references. Wait a freaking second. So, yeah, this is true. What if we do slices through pointers? That's an interesting. Do people even do that? Do people even do that? I don't think they do that. Can you pass slices by a value? That's very interesting. But at the same time, okay, so let's give it a try. So we're gonna have something like find, and in here I accept this thing as a const, right? So this is items. How do you even construct? So it's a thick pointer, right? So does it also mean that I can maybe pass it by a, not really by a reference, by a value? Which all use, yeah. So because if I understand correctly, slice is a small structure with two fields, pointer and a size, right? Do I understand correctly? Chat. Okay, listen. This is very important. This is very important for understanding how all of that works. Listen. Slice by itself is a small structure with two fields, pointer and it's, stop saying fat pointer. I know what is a fat pointer. Okay, pointer and a size, right? And that small structure is this thing. That small structure is this thing. Usually in Rust, when we put a reference in here, what we're doing, we're not passing really a slice. We're passing slice by a reference, that small structure by a reference, which also implies that what if I pass a copy of the structure? Is that something people do? The actual structure is unsized. Why would it be unsized if it has internally actual size? Or like the pointer has a size. What pointer? Not the array. What? You don't follow my trail of thoughts, or maybe I failed to actually explain my trail of thoughts. What pointer? I don't fucking know. So why can't I pass this thing? Because it is unsized. This pointer to this thing is, so by passing it by a pointer, I actually passing it by a value? Is that what you're saying? Doesn't make any fucking sense to me. Oh, that makes more sense to me now. Wait. This is bizarre. I think Rust developers are deranged. Like, what the how does that make any fucking sense? I don't fucking understand. So, anyways, I guess we're not gonna be doing any of that shit. So what we're gonna be doing is just this. Because none of that shit makes any fucking sense to me, right? They overcomplicated it, right? It should have been just, why a structure that holds two values, a pointer to the buffer and the size of the buffer, would be all of a sudden unsized, when in reality it does have a size of a pointer and plus, you know, the length of the slice. That doesn't make any fucking sense, right? So why would you make it unsized? So I don't know. My conclusion again, like the more I work with Rust, the more convinced I get that Rust developers are just simply deranged, right? So it's just like, that's the only explanation I can find. Like every time I see this kind of stuff, it's just like, I don't know. I think they're just deranged. But anyways, so this is what we're going to be doing in here. So we want to find something in here, some sort of a value. So the pointer itself is a small structure. Yeah, that's what bothers me. Like, why? It's just like, like, why? It's like you're not comfortable that you have some structure in here. Like, what? Anyways, whatever. I need a function, so that's just wasting my time. That's just, all of that is just wasting my time and not helping whatsoever. So what we need in here? So we need to have like an item in here. So it's usually called needle, by the way. It is usually called needle, and so let's actually try to search for this entire thing. So we're going to be doing something like this in count, like so, and then items add I, and we're going to simply dereference this entire thing. Oh, and yeah, so this is a little bit annoying in the sense that we don't know the key. Fuck, because we need to search specifically by the key. So maybe we can do something like find autovar. So because of that, we're going to be actually specifically looking for autovars, and the needle actually is going to be name, right? So it's basically the name, right? We're looking for that thing. Okay, so we iterating through the count. So then we add this entire thing, and if libc strcmp between this thing is name 0, we're just returning that specific item in here, right? So that's what we effectively are returning. Might as well maybe just have something as an item. Right, so this is the Emacs, shut the fuck up. Like, why did you freaking open that stupid menu? Right, so then we return an item in here, and otherwise it's gonna be ptr null, something like that. So this is gonna be the const, and so on and so forth. All right, so that's pretty cool. But at the same time, what if I want it to be mutable, right? So I feel like this has to be immutable, because internally struct array, this thing is immutable, right? So and you want to have a mutable reference in here. Yeah, so that's basically what I want to have in here. That's basically what I want to have in here. So now when I find this name, find autovar, I'm gonna grab this entire thing. So this is gonna be vars. I pass it by a mutable reference like so. And by the way, since I pass, well, yeah, it has to be items and count. Maybe at some point I'll figure out how to pass it by a reference, right? So how can I, so essentially I can just construct a slice out of parts and then do as a pointer. I think that's how I can do that effectively. So I can do rust up doc. All right, so let me go here. So from parts, so this is from row parts. I think it was, yeah, from row parts. Oh, you can also do a pointer. So some sort of a metadata, so this is not what we need in here. I think this is the slice. Yeah, okay. So I can always do something like this, where I have a data and the length, and can get a reference, and then through basically auto casting, right? So I can get it as a row pointer or something. Like, I didn't see any problems with that, I think. So maybe there is also from row parts mutable. Yeah, so there is something like that, from row parts mutable. So one thing we can do here, chat, one thing we can do here, which is rather interesting, actually, believe it or not, in the array, we can introduce something like array slice, where we just take this entire thing, right, like this, and it returns you literally like a slice of this internal thing. Right, which is effectively is ptr from row parts mutable, and it's like this. So we take let's take items. So this is items and count. Yeah, and it automatically will basically convert to that. Huh. This is really interesting. Okay. So, and then since I'm searching, like I can actually, yeah, so we can do something like vars, and this is like this. That's kind of interesting. Okay, so but does it also mean that I can simply do var in vars? Can I do? Maybe I'll have to dereference it first. Okay, so then within the var, this one is rather interesting, but if I don't dereference, maybe it's going to be a pointer. So then in here, I can do var name, and then I can probably return a var. I wonder if this shit is going to work. This is awesome, honestly. This is awesome if it's going to work. So let me remove that because obviously it doesn't compile. So I just want to see if this specific thing compiles or like how it's going to work. Okay, so what do we have in here? Yeah, obviously it has to be a generic, right? So that's very obvious. This one returns a pointer null unresolved pointer. So you're telling me that we need to use core ptr or something in here. All right, so and it also, so that's what is it like? Use a freaking, like, why everything, like, this is such a systematic fucking shit. Like, this is not a single instance. Why anything fucking useful is a nightly? Like, what the fuck? This language is 13 years old. For 13 years old, they can't stabilize the useful feature of this language. I just fucking can't. Like, holy shit. Get your shit together. Fuck. Ugh. Okay, wait a second. So, and it's part of the PTR or... Oh, it's not a PTR, it's a slice. I'm sorry. But I mean, I just want you to schizo-rant. I just... right, it's a part of the slice. But wait, does slice even exist? Yeah. So what the fuck are you saying? Yes, I should have not removed this thing. I'm just like, I'm so got used to bullshit of Rust that I'm just like automatically expecting it. So it's not an iterated tricolon iter. Okay, so can I just dereference it then? So it is not iterable. Okay. So if I do iter, is it going to give me something? I feel like no method iter. So you can't iterate slices because we don't have std. We don't have std, so that's kind of interesting actually. Dereference and bro, this is cheating. This is cheating. No, we can't do that. But I mean, it may technically work. Right, so, and yeah, so you end up trying to return a reference instead of actual pointer. So this is not how we're gonna be working, I'm sorry. So it's just gonna be something like that. So this one is rather interesting. But I mean, but iter is probably, you guys are so obsessed with iter. It's going to be fucking slices. You're trying to piss me off, right? Like, I do understand correctly that you're trying to piss me off. It's gonna be slices, wouldn't they? Right, so okay, let's give it a try. So I'm gonna stop listening to your chat. You're just like trying to piss. Obviously, you fucking obviously, right? So it's gonna be a slice. We can't use slice. Right, just trying to piss me off. I get it. I get it. So let me see how we're gonna be approaching this entire thing. So let me just try to do these kind of things. So obviously you have to dereference it, otherwise it's not gonna just let you do .len, right? Do you understand that correctly? usize cannot be dereferenced. Oh yeah, this is because it's I. Right, so this is just I. By the way, I'm surprised. Wait. You can do .len on a row pointer without dereferencing because that thing is that slice. It's that thick. I think I understand that and I fucking hate it. I think I understand why you don't have to dereference this thing and I really fucking hate that. Because usually you have to dereference the row pointers, right? Because it's like they don't auto dereference it, but this one you don't have to dereference it because this is not a pointer. This is a thick pointer. This is not a one number 64-bit number. It's actually a structure. Again, the more I work with Rust, the more I'm convinced that the developers of this language are deranged. So curvy pointer, yeah. So let me pour some water. Just a second. Let me pour some water. So you basically have the same syntax for two semantically different things, right? So slice like this and a pointer are not the same things. References and pointers share the same structure. Whatever. Okay. So so what do we have in here? This is going to be something like that. And if I want to... So you're also telling me that I should be able to do this kind of thing. Right. Yep. And then I can do vars I, but is it going to work properly? Let me see. Cannot index auto var. Okay, that's very interesting. So that means I probably can do something like add. But it wanted to have this unwrapped. The size of the value cannot be known at compile time. Okay, so what was it saying? Wrapping add. Why did it have to be specifically wrapping add? Wrapping add. So let's try to maybe dereference this entire thing and then index it. Right? Aha. So and then I'm gonna try to dereference it, and then can I take a like pointer of this? It has to be mutable, sure. What else do you want from me? So expected mutable return type. So was it but it didn't automatically. This is a very rare case when it didn't automatically convert, but if I do raw mutable, expected mutable but got auto var, but T is auto. This is because it's, yes, should have been actually auto var, by the way. So let's actually do, yeah, I forgot to update some of these things in here. So that makes sense. Mismatch type because of mutability. Okay, so I'm gonna try to do that. Lipsy call to unset. Well, I mean, shut up. Finally. Was trying to use their stupid ass slices even, like, was it even worth it? Like, it's just easier to pass like a size of this thing manually. Like, what's the point of that? Like, what does it add? Like, it just adds a little bit of inconvenience, and I do not even fully understand what the fuck is this shit. Like, why? Why are we doing it this way? I mean, well, I mean, we can finally iterate arrays that we point at through this sort of syntax. At least we have that. By the way, I probably can remove raw. Yeah, I can remove raw. Like, I'm looking at this, like, I kind of understand what's going on in here, but I don't understand if it's worth it. Like, is it really worth it to do it this way? So I feel like it isn't worth it, but whatever. Okay. So Now, so this is what we're trying to do in here. So array slice, right? So we've got this kind of thing. So I can do array slice. Funnily enough, by the way, I'm passing it by a mutable pointer, but do I really need to pass it by a pointer? Because it's a very lightweight structure. I can just pass it like that. I think it's, yeah, I should just pass it like this. It should copy it. Right, so then I can do something like that, and then I just pass this name in here, and I think it should just work. Right, and then we can have something like existing var, right? So this is existing var, and if existing var, is there something like is null for the pointer? Yeah, so if existing var is null, maybe there is something like is not null. Do you have is not null? Yeah, as not null. Okay. If it's not null, we should maybe print something like this. So redefinition as error redefinition of variable s. And this is going to be that thing. So this is the redefinition, and then maybe we can, I freaking know, return 69 in here. Right, let's go. So what do we want in here? Array slice, it's a ds. What else do we have in here? Aha, so we don't have to dereference that stuff anymore, right? So because we're accepting it by value, we don't modify it. All right, so that should just work. So vars. So we're just printing this entire thing. So what are you complaining about? Move occurs. Move. The fuck are you saying? How is that? Ah. Auto var. I didn't declare this entire thing as derive. Clone copy. Alright, so if I try to do B, redefinition of variable A. So I got the redefinition of variable A, and I can now do something like that, right? So, and now it works. There's no redefinition of variable A, but we don't really report where exactly that happened. We don't report where exactly that happened. Though we can keep track of the location of where the variable was defined, but we can actually do that a little bit later. It's not actually that difficult because we already have the location, right? So I think it's stb. So I remember like expect. Am I in the right place? I feel like, oh, it's a completely wrong one. So this one is a BRS. Expect. So yeah, so here we can, every time we declare a variable, we can just get its location, and we can store it in auto var, so that way we know where it was declared. So then when there is a redefinition, we can report, okay, this thing was defined there. But I mean, it's kind of like a cosmetic thing. We can obviously implement that a little bit later. So, and I'm going to put it to do in here, essentially saying that report where is the original definition, something like that. All right, so now I don't have to worry that, you know, I accidentally defined the same thing. So the names in the var array should be rather unique. It should be rather unique. So which is cool. Okay. So here is the name, like what we're trying to assign in here. So this is the name. And if it's equals, right, so we have to basically see if that variables exist anywhere. So let's do find autovar. Find autovar, we provide this kind of thing, and then we just return that. So var definition, I'm going to put it in here, and if var definition is actually null, we have to report that could not find that specific variable. So what we have to do in here is essentially say could not find variable s, and then we just return 69. But in this specific case, we can actually report the location, right? because we're currently looking at that specific thing. So get location. So that's how we do that. So first we have to, yeah, so we don't really report it std error, but we probably have to do that. So here is the location, and here is file path, line number, and line of set. So let's put all of that stuff in here. So there is this extra space in here, which is a little bit annoying. So that means it existed up there as well. I just accidentally put it in there, which happens. So that's totally fine. That's totally fine. We don't need that stuff anymore. Okay, so couldn't find the variable if it doesn't exist. Okay, so I'm gonna try to do this kind of thing. Redefinition of variable a, okay. So maybe I'm gonna do simpcmod, and in here I'm gonna just say okay, comment it out. So that's totally fine. Now we have that. I can also try to do something like c, and that still worked. So maybe I forgot to recompile. Let's try to recompile. So it didn't even compile. Yeah, so that's basically what happened in here. I didn't properly compile. So this is just a L, and I suppose here I have to take a mutable reference of this entire thing. Maybe not. There we go. So could not find variable C. As you can see, it points at that. Cool. Couldn't find variable C because it doesn't exist. But if I do A, it does in fact exist. Okay, that's cool. That's very fucking cool. But a location is actually fucky wacky. It's a location of equals instead of location of the name. So we have to be a little bit careful with this kind of stuff. So I wonder how can we can just take the location like this. Yeah, let me try. So this is the name location. Yeah, so here is the name, then the name location, and this is the name location. That's how we approach all of that stuff. So we get the name and we instantly get it location. So then when we need to report stuff, we just use the name of the location. So, and now if I try to use C, yeah, it now points at C. Cool. So we can basically, the problem with get location, by the way, and even Sean Barrett himself said that in the documentation of this thing, is that this thing is fucking slow. This is an inefficient function, returns the line number and character offset of a given location in the file, blah, blah, blah. But the idea here is that you only use it for error reporting, right? So, and errors don't happen very often. So essentially, it's just linear. It scans the whole source code from the beginning. That's why it's so inefficient. So doing this thing on each individual token is very slow. So you shouldn't do that. But doing it on errors is fine. And maybe occasionally in strategic places, right? So every time we encounter a name, we can do get location. But I don't know how fast it is, right? So it would be better if, you know, the location was properly computed as you tokenize things, but this tokenizer doesn't do that. Right, so maybe some sort of what to do in here. Getting location like this very often is too slow with stbc lexo.h. So that's kind of a problem in here. That's kind of a problem here, and we have to be aware of it. Anyway, so we got the thing, we got the variable definition, and we basically know its offset within the variable. So the next thing we need to do, we need to parse an expression. We need to not only parse the expression, but also compute the expression. Store the where instead of locate. That's a cool idea, honestly. That's a cool idea. That's actually better. Yeah, that's pretty cool. Just store the where and yeah. Okay. So name where, which is where first character. You guys are smart, apparently. Sometimes chat says some interesting and smart things. God damn. Okay, so here is the location, right? So here's location, and here we take just the lock, but where is actually name where. Chat loopbox, exactly, chat loopbox. And honestly, we can also store where in auto var. Yeah. Fuck you, Rust. Fuck you. Why, like, so you can do that like that or something. I don't fucking know. So yeah, where, and so for the first character, and oh, it's actually mute cchar. Huh. Mute cchar. Where underscore, but I mean underscore means that it's not used, isn't it? I don't remember exactly, but oh, whatever. Auto var. So, and where we can just do L where first character. So this is what we can do. And by the way, that just also means that if we encounter redefinition, we can report that properly. But let's not waste time on that. Let's not waste time. We already wasted a lot of time, so we're already streaming for 1 hour. I want to make a small break, chat. I want to, you know, refill a cup of tea. And after we refill a cup of tea, we're going to continue doing this whole stuff. I feel like I spent too much time on diagnostics, right? So I shouldn't do that. We need to have a working example by the end of the sessione, right? So what do we have in here? Offset. And where I never used. Who gives a shit? Okay, so this one is A, and this is what we got. Okay, so let's make some break. We're back. So I think I need to cut a little bit of corners, right? So because this is already second session, and it's already the second hour of a second session, and we're nowhere near where we want it to be, which means that we really need to cut corners. Let's go ahead and try to maybe instead of having 2 variables, let's have 1 and directly maybe have 69 in here and just do something like this. All right, so this is a simpler program. And here we're going to have declaration of a variable, then writing something into the variable, then reading from a variable and passing it to a function call. Right, so this is a little bit easier and probably will take less time for us to implement within a single session. All right, so this offset is not available anywhere. And when we do an assignment, since we're only assigning digits in here, I might as well just like read only a number, right? So we're going to be reading only a number. We're going to be specifically expecting a number in here. So where is the expect class, right? So we are specifically expecting in here a number. So I think it's stb selecta class, and it was int. Was it int lit, right? So it was int lit in fact. So if it's not that, we're gonna basically fail in here, right? So you can only assign numbers for now. Again, like later you can always actually expand that. Right, add some stuff in here. Maybe we will do that at some point. So what's gonna be the next thing? I suppose we just need to write an operation that just like saves that stuff into there. And I wonder how we can do that. So I kind of forgot how to, like, you know, save a value into a particular memory region. So we may want to do something like RBP, and we need to subtract a specific offset of the variable that we know in here. So I can do var definition, and this is the offset, and offset is actually usize, so that means we have to use u in here. So, and we need to literally save a value in here, and the value is whatever we have in int number. Was it? Yeah, it is int number. So that's basically what we're doing here. So yeah, I guess that's it, right? So we're just saving that thing into a variable, at least for now. Doesn't compile, obviously. Let's go through all this stuff. What exactly do you want from me? I think it wants me to cast this entire thing to i64, right? So what else do we have in here? So it doesn't like something in here. What? I don't get it. I think I forgot to put C in here. Happens. Right. And that's basically expected 260 but got 59. Ooh. Ah, I do remember that. So that means after we got the integer literal, we have to expect a semicolon, right? So because that's how we separate statements in this compiler. Yeah, there we go. So that's basically what we got in here. In fact, now we can actually have a variable amount of stuff in here, so we can do a bunch of assignments and they all get translated into this weird thing. Right, if we had several of these things, all right, so something like 34 and 420. Actually, I mean, we could have two variables. Who said we can't do that? Yeah, so for example, here, there you go. You have two variables in here. So, and we just, yeah, why not? It's kind of funny. But again, for now, let's just like have only one variable, right? So it's going to be 69. Okay. The B compiler, B. All right, and so since we kind of expect specifically only variable reads in here, we might as well only parse a variable read. So by the way, expect a note expecting only int literal here for now. Right, so and in here we're going to be expecting only var read here for now. So what that means, that means that we need to do collects one more time, expect collects, and specifically what we're expecting is an ID, right? So we're specifically expecting an ID, and that ID is going to be var name. Okay, so this is a var name. You know what's interesting? Is that we need to repeat this diagnostic of not found variable, which gives me an idea that maybe I have to tuck it behind find variable. I think that would be a cool idea, right? So just tuck all of that behind find variable. So because if you can't find a variable, just report the diagnostic and we're gonna exit anyway. So let me give it a try. I'm gonna grab this stuff, find auto var. So, and if you couldn't find it, just like print that. And then we're gonna return null. I should have actually not removed null, right? Because that's literally what you have to do in here. So, okay, let's go back where we use all of that. Might as well actually do something like this. So now, so this is variable name. And I might as well actually do this thing, so I don't have to do it like that. Kind of like that. Okay, so now let me try to compile it and go to the compilation errors. Okay, this is interesting. So if you to report anything, we'll need a pointer to the Lexa. Right. So let me see how we accept the pointer to the Lexa. So this is what we need to accept in here. So let's just put this stuff in here. So this is the Lexa. You must provide the Lexa. But since it's already a pointer, we don't have to do this kind of stuff. So what else do we have to provide in here? Name where. Okay, this is important. We should accept it in here like this. So it's going to be mutable char. And what else do we have in here? Okay, so mutable L, and also L first, where first character. So we get this thing. We provide the name and the first character, and then it will report everything for us. Ooh, no, this is bad, right? So because sometimes you actually need to report. Yeah, I'm an idiot. Backtrack all of that. Backtrack. You should not be tacking it behind. This is bad. This is bad. Right. So I just wasted a little bit of time because I was not very cautious about this kind of stuff. Yeah. Okay. So that means like we have to be really like we have to report something in here when we cannot find a variable. We can do a little bit of a copy paste, right? So I just didn't want to copy paste too much, but apparently I do have to copy paste, right? So even though, yikes, yikes. So let's do it like this. I might as well just do L string. So this is what we have in here. So we've got the variable, and then we get the location of the name in here, but is it really a name? So name where, it's more of a like a where first character, right? So and then we say could not find variable, location line, blah blah blah, and the name here is L string. All right, so okay, that's cool. That's cool. So that's basically what I wanted in here, just like a variable definition and stuff like that. Copy paste in the string, refactor afterwards. Exactly. Exactly, fucking. All right. So, and that seems to be working more or less. So if I try to use a variable that doesn't exist, something like C, because B does exist, so it's not going to work. Yeah, could not find variable C, and I mean, yeah, there we go. So it couldn't find this specific variable, which is cool. All right, so, and now I'm performing a function call. If the functions right now expect only one argument, which is a function variable, right? So that's basically what we're doing here. And according to x86-64 convention, right? So what we have to do in here is essentially move into RDI a value from a memory RBP minus the offset. It actually has to be 0. So that's what we have to do in here. And that our offset is in a variable definition. All right, so this is just the offset, like so. And that's it, honestly. And well, then we have to perform the call, right? So we have to perform the call. So let me see. So we have to call to the function, and the name of that function is just the name. And this is not particularly correct, right? So because we also have to keep track of the external declarations, similarly to the auto declarations, right? So we have to kind of do a similar thing in here. Right, and that should be enough, honestly. There we go. So what do we have in here? So it didn't like something about FMT because, yeah, I forgot the C literals, colliterals, as we say in the industry. All right, so do one in here. It was, yeah, so we're using incorrect variable in here. Okay, so after that, we expect a bunch of things in here. We expect closing parent. All right, so we expect a closing parent and a semicolon. That's the things we expect. Right, so, and then this is rather interesting, right? So this is rather interesting. We are doing that in a loop, but we need to know when to stop. Right, so we may encounter extern, we may encounter auto, and at some point, so we probably encountered something interesting. Yeah, we have to, yeah, this one is funny because we explicitly expect ID, but it may not be ID. So what we have to do get, how do you just get, stb lexa, how get, where is the get, how do you get, there we go, this is how we do get. Right, so essentially you just have to do get, right? And if L token is actually equal to closing curly brace, you just assume the end of the function, right? So by the way, here we have to do expect otherwise, right? If it's that, what essentially we have to print in here, we have to, I think, print the epilogue of the function, right? It has to be epilogue of the function. And the epilogue of the function is going to be basically, first of all, deallocating all of the local variables. We have to deallocate all of the local variables. Luckily, it is actually super easy because we do know how much we already allocated through vars of set. Through vars of set, we kept track how much we allocated on the stack. Well, we could do enter, leave, and stuff like that, but I don't remember how to use them properly, so I'm not going to be using them. So I'm going to do add RSP, and basically ZU, which is a vars of set, right? So we are offsetting everything back. So it's a vars of set. So something like this. This has to be C. Then we have to restore RBP. So we restore it RBP like this. And then I suppose we have to return out of this entire thing. On top of that, by the way, we can also move rax 0. So because we're returning out of the function, right? So by default, we can just return the 0 exit code. We can just return 0's exit code. And after that, we have to break out of that loop. And that's going to be basically the end. And then here, I suppose we just return 0. Okay, if it was not that specific thing, and we probably have to do as I64, we check that it is specifically ID. So we expect either closing curly brace or ID. And if it is ID, we check specifically what kind of ID is that. And depending on that, we'll already parse and generate different kind of thing. That's basically it, I think. That is basically it. So let's actually see. So let's actually go through all the compilation problems in here. So it has to be mutable. Sure. And I think it generated some scheisse. There we go. So it generated an assembly. We can try to do that one more time. We can save that assembly. So this is main asm, right? So, well, I mean, I have to redirect that. So let's do T. And now I have .main asm. That's kind of interesting. So listen, let's give it a try. I'm going to create a make file. So main asm depends on main B and B. And what we do in here, we just call B and we just redirect to that to main asm, right? So let's actually try to specifically build main asm. Well, I mean, let's rebuild all of that. So I want to go through all of these warnings in here. So it's not used right now. So there we go. So this is what happened. We basically build the compiler, then we build third-party dependencies, right? Build a third-party dependencies. Then we created an assembly file, and here is the assembly file. So the next thing with the assembly file is going to be creating main.o out of that assembly file. By the way, we depend on this shit, which we shouldn't, I think. We don't even create it anywhere. So stbds, it's sort of like a leftover, and we don't really need stbds in here. So we only need stb selector and nob.o. So we depend on main asm, right? And the way we compile this entire thing is just fusm, right? So we just use fusm to compile main asm. Right. So let me grab this entire thing, and I want to try to build this entire stuff. Okay, so it doesn't build. This is exactly what I wanted to see. So it failed at operand size not specified. That's fair. That is actually fair. I didn't think about that. Thank you. So I think it's a keyword. Yeah. Let me see. I want to find all of the moves. Right. So this is that move. This is keyword. This, we don't have to specify it, right? So because it knows that it's keyword from the size of this register. So, and that's it. I think that's the only thing that was in here. Okay, so did it create a main.o? It did in fact create my main.o. So, and we have to create the final executable out of this main.o, right? So we're gonna depend on main.o, and the way we create it is like this. We're just linking it all together, but we're linking it without, you know, position independent code, right? So because we didn't properly use PLT operator in FASM or anything like that, because we're a little bit lazy today. All right, so now let me try to just build the final executable and see if it's going to work. Right, so let's take a look at the main B program in here. So main B program, effectively saves 69 into a variable a that is allocated on the stack, right? And then it feeds that variable into put char. So the code, the ASCII code 69 is actually E. So if after compiling this program, we run this program and we see E, we succeeded. Fuck yeah. So we wrote a very basic draft of a B compiler in a span of 2 sessions. And I didn't do any development between these 2 sessions, right? So it's just like, it took us 4 hours to create this kind of thing in Crust specifically. But on top of that, I mean, I had the chat in here sitting in the corner constantly distracting me, so absolute coding. So what's funny is that, again, you can just do different things in here. For example, I can reassign it again to 68, right? So, and I can rebuild the whole thing like so, and now it's D. Right, so, and it doesn't optimize any of these reassignments, right, so it directly just uses them. And by itself, it's kind of a useless language, honestly, so it's 34, 35. It would be kind of cool if I could just sum these things together, but I really can't. Right, and as you can see, it complains about this kind of stuff, right, so it expected one thing, but got another one. Right, but it's only a start. This is how I usually start developing the languages, right? So I start with like a very basic hello world example, and I just make it work. And now we have something to work with. Right now we don't even have separate functions, honestly. That's very interesting. What if I had something like foo? So here's the function. And I basically would move all of that stuff into this separate function and then just call this function. That would have been interesting to make, you know, to compile. Right, so if I just try to specifically build main asm, how it's gonna look like. Right, so yeah, so the problem here, look at that. It compiles only one function. So that's the problem in here. It compiles only one function. But and if I got, you know, semicolon. Well, I mean, it didn't try to even compile the rest of it because it just like found one function, right? And then it stopped compiling because like you can only have one function. But what if we had several functions? Let's actually see. So can we extend it so it can parse several functions? Here in a loop, we keep parsing the statement of a function. We keep parsing the statement of a function. So that means we need another loop that keeps parsing functions, right? So you have an outer loop that keeps parsing functions and inner loop that keeps parsing the statements of the functions, right? So we have to do loop in here and down there, somewhere here, like this, right? And we can be, maybe we can have some labels in here. So if I remember correctly, it's something like this. So this is the label, it's going to be statement, right? And this is going to be func. Right, so this is func. And I did use breaking here, and we're breaking out of the, believe it or not, we should be breaking out of the statements, right? So this is like statement. Maybe we should call it body. Yeah. Break out of the body. So you encounter this thing, you break out of the body. So in a function, this one is interesting. So we either going to get an ID or I suppose the end of the stream. And then we probably have to do a similar trick in here, right? So we just get the next token, and if that next token is end of file, we break out of this entire thing. If it's not, we assume it to be ID and we continue parsing all of the functions in here. So we'll give it a try. I'm really curious what's going to happen. So it complains unused label. Could you please shut up about unused labels? But anyway, so this one is interesting. So it actually almost worked. Look at that. So it compiled function foo. Then it started compiling function main, and it encountered problem in here because it expects a variable, at least one variable in a function call. So we only support functions that have one argument, and that argument must be a variable. But now we have functions without any arguments. So let's actually add support for function without any arguments, right? So, and that's how you basically, you know, develop a compiler, like slowly, steadily, looking at the cases and just adding them and stuff like that. So where is the function call? So function call is somewhere here. So here is the function call. And then, okay, so we specifically expect ID, but let me try the following thing, get token. Right, so first of all, we get the token. And then we need to check, what's that token? So that token, if it is equal to closing curly braces, that means you didn't provide any arguments in here. You literally didn't provide any arguments in here. And in that case, I suppose we can just simply call that function. So let's do something like this, for call as, and so what we're calling in here, just calling the name, right? So we're just calling the name and that's it. Otherwise, if it's not that, we do the rest of the thing, right? So we do the rest of the thing. But we also should not forget, we could probably compress these two branches somehow, but I don't want to do it right now, right? Anyways, so yeah, essentially, if you have open parent, you don't have any arguments. If we have some arguments, you would do something like that. You can probably invert this kind of thing so it looks a little bit better, but I don't want to do it right now. And once you invert it, then the next logical step is going to be transforming it into while loop that actually munches on the arguments of the function call and populates the registers according to x86-64 convention. But again, I'm not going to be doing it right now, so it's kind of like the next logical steps in here. Okay, so it complains about some stuff in here. Oh, I apparently did this thing incorrectly. So this is because after I get it, I don't have to get it the second time, right? So what I have to do in here is just like this. Okay, so this is cool. Look at that. So it tried to compile main, but then it failed because I forgot what? Chat, I forgot what? I forgot the semicolon. Right, so and now at the end in here, it's still, right, it kind of worked, but at the same time, oh, I see. So it got 256. It got 256. If I take a look at what 256 means, it's an end of file, which means that we got to the point that I was talking about, chat. We got to the point that I was talking about. Let me see. So we have to get token in here, right? So we're getting the token, and if that token, L token is equal to stbc lexec end of file as i64, we are breaking out of the function, right? So we straight up breaking out of the function. We processed the entire file. Right, if it's not end of the file, we parse this thing as usual. So now, as you can see, we're now capable of compiling two functions. You see, it's like, this is exactly what I was talking about. Like, you start with a very dumb, simple example, and as soon as you have something working, it is extremely easy to keep expanding it, right? You support one function, support multiple function. You support function call with one argument, now you support with 1 and 0. What if you want to have 3 arguments? Okay, it's easier to add, you do while loop. You see, it's just like you start putting more meat on this kind of thing. So it's twice as good. Well, I mean, it's not just twice. Now I can have arbitrary amount of functions in here. So, and if I take a look at assembly, it does make sense, right? So these are like legit functions. These are legit functions. Adding binop, you can then at some point add binops, right? So you already have a compiler, very shady compiler, but it's actually very easy to make it less and less and less shady. Right, so. Okay, so now let's try to build the O file. And assembly actually managed to assemble this final file. It actually managed to assemble the final file. And so can it assemble the final executable? And there we go, the final executable. And compilation illegal instruction. So I don't know what... Isn't that poggers? Isn't that poggers? So let's actually try to troubleshoot. So maybe, so what do we have in here? What exactly is wrong in here, meine Freunde? Yep. So this is a public foo. So yeah, failed successfully. Exactly. Interestingly, if I take a look at the main adds RSP8 for... I know. Do you guys know what the fuck is wrong in here? We actually had tracking for variables of set and stuff like that, but it was assuming only one function. So this is like a local autovars, by the way. This is a local autovars, but they now share between all of the functions. So we must have this kind of thing for like separately for each individual function actually. So, and I suppose the easiest way to do that is basically reset vars and var of set on each iteration that's parse function. Right. Well, okay, so listen, we are programming in Crust, right? So move it inside of the loop. We are programming in Crust. There's no automatic array AI memory management or anything like that. You're going to be leaking memory if you just move this thing inside. So what you have to do, you have to reset this array and this var on each iteration, right? So it's basically shared between all of the iterations and you reset it. Basically the thing that you would do in C. This is how you would approach in C. You wouldn't put in C this thing inside of the loop. You would be resetting, right? So because you manage your memory manually. Right, so this is what we're going to be doing here. So we don't have like a drop trait because implementing trait requires using references. So I have questions. I know that's the whole point. But anyways, so let me see. By the way, I would like to maybe do something like this. So let's see if this compiles. Let's try to maybe do awesome and see if it does things. Yeah, look at that. So this thing allocates a local variable and then at the end deallocates this local variable. Main doesn't do any of this shit, right? So we don't do any of this shit. So that means it should be okay. So can you assemble this thing now? So it complains about some warnings and stuff. Mutable assignment to variable is never read. What are you saying, broski? It is red. It is red. And what are you fucking saying? You mean initialization in here is never read. Oh my god, why are you so anal about this? It's complaining that this specific zero assignment is not gonna be ever read because I rewrite it in here. Is that considered a useful warning in Rust world? How is that a fucking useful warning? Like it's a deranged language, like Jesus Christ. Safety my ass. Anyways, so this is the thing. So now let's try to create a final executable, and we got E. Here's the cool thing now, chat. Here's the cool thing. Now I can call foo multiple times. So I called it 5 times, and so if I rebuild the whole thing, now I have 5 E's. Like, I have already working compiler, like I can do things in here. So I can have bar, which essentially, like, we have this kind of thing, and maybe I can have some other things, right? So 68, right? So this is going to be 68. And in here, I can maybe do foo bar in here and just call it. And it says, oh, you can't have extern multiple times. That's fascinating, honestly. So simple already defined. So you can't do that. You know what? I can actually do it like that. Boom. I go ed, the standard text editor. The standard text editor. Isn't it cool, right? That we have like a very stupid compiler that can compile this more or less correctly. I think this is fucking cool.
Right, so only 4 hours and it already feels like, you know, a compiler, right? So you can keep adding more and more features into it and it's gonna be usable. So can you call main and main? You can. So let's give it a try. Main. So yeah, we already have recursion. So and it killed Emacs, by the way. So I'm just saying. So we're gonna put B and let me run this thing. Yeah, there we go. And it's sec faulted at the end. So because it caused the stack overflow. No, it overflowed the stack. There we go. More or less legit programming language, right? It looks like a programming language. It doesn't have ifs, while loops, but you can allocate some variables on the stack, and that's really cool. I really want to continue developing this thing. It's fun. It's legit fun. Yeah, exactly. Who needs loops if you have recursion? Like I can already do recursion in here. So if we, I don't know. So do we have plus equals in B? I think I vaguely remember that we did have plus equals. I think it was equals plus. Yeah, it was equals plus. It's kind of a different one. But we can try. Yeah, so that requires a different tokenizer. Plus plus. Okay, let's try to implement plus plus. Let's try to implement plus plus. I think we can do that. So super quick. All right, so anything that is very easy to implement, I think we should try to do that. I think it's going to be fun. So main, all right. So we can start with foo probably. And, so that requires actually global variables, I think. Right, so we don't really have global variables. That's a lot of implementation, unfortunately. We have Shrek. Global variables. So if we, yeah, we can try to have global variables, but that means we have to allocate them in a static place somewhere. That's a lot of work, honestly. Like I don't think I can hack it quickly to get it. What I want you to do is basically print ASCII characters from 0 to 256 and just go to infinity. But how can I easily do that? So I don't think I can easily quickly hack it together, unfortunately. I can maybe pass this kind of stuff through parameters, but I mean, this requires implementing parameters for the functions. So yeah. Well, we can implement that later, right? We can implement that later. Okay, so wasn't it fun? I think it was fun. Finally achieved what I wanted to achieve with this series, with this specific session, right? Unfortunately, I underestimated myself a little bit. Just a tiny bit, so I thought I will be able to do that within a single session, right? But it took 2 sessions instead. Happens. I'm not perfect. I'm not a 10xer, unfortunately. Ah, fuck. Okay, I killed my Emacs yet again. But yeah. All right. So let me take a look at some of the subs. And thank you so much for tier 1 with the message 34 years. 34 years indeed. Is it? Yeah, it is 34 years. Valene, thank you so much for tier 1 with the message Atsoding cool indeed. Will we continue this compiler? I don't know. We'll see. The winner gets tea, that's for sure. So I first need to upload these sessions to YouTube, see how they perform, see if people are interested in this kind of stuff, and maybe we can continue. I'm down to continue this thing. I think it's fun. I would love to maybe even make it self-hosted, but I mean, I already did a self-hosted meme, so right. I don't know. We'll see. All right, that's it for today. Thanks everyone who's watching me right now. I really appreciate that. I hope it was fun. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzin. I love you all. Mwah.